Question: which out of the following is the correct equation to show change in molar conductivity with respect to concentration for a weak electrolyte, if the symbols carry their usual meaning? Let Ha be the weak electrolyte. This dissociates to give H plus and A minus ion. If the initial concentration is 1 m, then initially concentration of Ha, this is aqueous solution, this is 1 m and H plus ion is 0 and A minus ion is 0. If degree of dissociation is alpha, then out of 1 alpha moles dissociate, alpha moles of H plus ion and alpha moles of A minus ions form. Now when the concentration is C moles per liter, then all the values get multiplied by C. Therefore C into 1 minus alpha, C alpha, C alpha. Value of Ka will be equal to concentration of H plus ion multiplied by concentration of A minus ion divided by concentration of the weak electrolyte. Putting the values, this is C alpha into C alpha divided by C into 1 minus alpha. C gets cancelled. Rearranging the equation, Ka into 1 minus alpha is equal to C alpha square, and this can be written as C alpha square plus Ka alpha minus Ka is equal to 0. अब अल्फा की जो वैल्यू है, it can be written as, it is equal to conductance of the electrolyte at a given concentration divided by conductance of the electrolyte at infinite dilution, or it can also be said limiting molar conductance. Putting the value of alpha in this equation 1, the equation 1 becomes C into lambda square m divided by lambda naught square m plus Ka into lambda m divided by lambda naught m minus Ka is equal to 0. Now taking 1 by lambda naught m as common, inside the bracket lambda square m divided by lambda naught m into C plus Ka into lambda m minus Ka into lambda naught m, and this is equal to 0. Now rearranging this equation, the final equation is lambda naught m, when it goes to the right hand side it becomes 0, and the final equation is lambda square m by lambda naught m into C plus Ka into lambda m minus Ka into lambda naught m, this is equal to 0. Now multiplying both the sides of the equation 2, that is both left hand side of the equation and right hand side of the equation, by lambda naught m. The final equation is lambda square m into C plus Ka into lambda m into lambda naught m minus Ka into lambda naught square m. This is the final equation and this is equal to 0. So option 1 is the correct option. This equation 2, it is multiplied on both the sides by lambda naught m. Then we get this final equation. Question 2. Molar ionic conductivities of divalent cation and anion are 57 and 73 respectively. The molar conductivity of solution of an electrolyte with the above cation and anion will be: divalent cation molar conductivity is 57, divalent anion molar conductivity is 73. Then the electrolyte with the above cation and anion, its molar conductivity will be, that is conductivity of Ca will be molar conductivity of the cation plus molar conductivity of the anion, and this is equal to 130. Correct option is option 2. Question 3. The standard electrode potential M3 plus ion changing into M2 plus ion, means this is the reduction potential for vanadium, chromium, manganese and cobalt are. These are the values of the reduction potential respectively. The metal ion which can liberate hydrogen from a dilute acid are. Now, vanadium ion and chromium ion, their reduction potential values are negative, that is minus 0.26, minus 0.41. H plus ion has reduction potential value 0. So vanadium ion and chromium ion, they have reduction potential values less than H plus ion. So in the solution, if H plus ion, vanadium ion and chromium ion are present, then H plus ion having greater reduction potential than vanadium and chromium ion will accept electron and change into hydrogen gas. Vanadium and chromium ion, since their reduction potential values are less than H plus ion, they will not accept electron. So vanadium and chromium ions will be able to liberate hydrogen from dilute acid. So correct option is option 3. Now what about manganese and cobalt? Manganese and cobalt. Manganese has reduction potential value plus 1.57 and cobalt has reduction potential value plus 1.97 and hydrogen has reduction potential value 0. Now as can be seen, both manganese and cobalt, their reduction potential values are greater than hydrogen. Means if in the solution manganese ion, cobalt ion and H plus ion are present, then in the presence of electron, manganese and cobalt having greater reduction potential values than hydrogen will accept electron and they will change into neutral manganese and cobalt atoms and hydrogen remains in the solution as H plus ion. So manganese and cobalt will not liberate hydrogen from dilute acid. Instead, they will accept electron and change into neutral atoms. The product which is not obtained during electrolysis of brine solution is, brine solution means NaCl solution. So NaCl present in the solution dissociates as Na plus and Cl minus ion. H2O will dissociate in the solution as H plus and Cl minus ion. Now reduction potential value of H plus is greater than Na plus. Therefore H plus accepts electron and it is liberated at the cathode as hydrogen gas. And Cl minus ion, the oxidation potential of Cl minus ion is greater than the hydroxide ion. So chloride ion is oxidized at the anode to give chlorine gas. And in the solution, sodium ion and OH minus ions are left forming NaOH. Now this NaOH being a strong electrolyte remains mostly in the dissociated form, that is in the form of Na plus and OH minus ion. Therefore, the product which is not obtained during the electrolysis of brine solution is HCl. Option 1 is the correct option. NaOH, chlorine and hydrogen are obtained in the electrolysis of brine solution. HCl is not obtained in the electrolysis of brine solution. The reaction half H2 forming H plus ion and AgCl solid forming Cl minus and Ag solid occurs in which of the given galvanic cell? So H2 to H plus and AgCl to Ag. So correct option is option 2. This is the galvanic cell in which this reaction takes place. Which one of the following statements are correct? A. The M3 plus to M2 plus reduction potential of iron is greater than manganese. This statement is wrong because reduction potential for manganese is greater than iron. The higher oxidation states of first row D block elements get stabilized by oxide ion. This statement is correct because the higher oxidation states of the metals are shown in their oxides and in their fluoride, because these are the most electronegative atom. A metal can form oxide in different oxidation states. Aqueous solution of Cr2 plus can liberate hydrogen from dilute acid. This statement is also correct because reduction potential of chromium is less than hydrogen. So when chromium and H plus ions are present, then H plus ion accepts electron and changes to hydrogen gas, whereas chromium ion loses electron and changes to Cr3 plus ion, giving electron. Magnetic moment of V2 plus is observed between 4.4 to 5.2. This statement is wrong. V2 plus, it has 3 unpaired electrons. Magnetic moment formula is n plus 2, where n is the number of unpaired electrons. So this is 3 plus 2, and answer is 15. So its magnetic moment is not between 4.4 and 5.2. So only B and C are correct. So correct option is option 2. The spin only magnetic moment, this will be square root of n plus 2. So square root of 15, and this is equal to 3.87. For lead storage battery, pick the correct statements. Now lead storage battery, it consists of lead anode and a grid of lead containing PbO2 as cathode. This is anode, this is cathode, and lead and PbO2. The electrolyte solution used is 38% of sulfuric acid. So lead plus PbO2 plus H2SO4. It will form PbSO4 plus H2O. During discharge, this forward reaction takes place. This is the reaction during discharge of the battery, or when the battery is in use, and the reverse reaction occurs during the charging of the battery. So in the reverse reaction, lead sulfate changes to lead at the anode and it changes to PbO2 at the cathode. So the first statement, during charging of battery, PbSO4 on anode is converted into PbO2. This is wrong because it is converted to lead. At anode it is converted to lead. During charging of battery, PbSO4 on cathode is converted into PbO2. Correct. Lead storage battery consists of grid of lead packed with PbO2 as anode. Wrong. Lead storage battery has 38% solution of sulfuric acid as an electrolyte. Correct. So statement B and D are correct. Choose the correct answer from the options given below. Correct answer is option 1, that is B and D only. Question: which one of the following statements is correct for electrolysis of brine solution? Brine solution means solution of NaCl. Now NaCl dissociates into Na plus and Cl minus ion. Cl minus ion goes to anode, and at the anode the reaction is Cl minus ion giving away 2 electrons and chlorine gas is evolved. At cathode, reaction taking place at the cathode is 2H2O plus 2 electrons forming hydrogen gas, and 2 moles of OH minus ions are formed. So correct option is OH minus ion is formed at cathode. Option 4. The delta E by delta T at constant pressure of different types of half cells are as follows. Where E is the electromotive force? Which of the above half cells would be preferred to be used as reference electrode? The half cells which would be preferred to be used as reference electrode will be the one for which the delta E by delta T value is the least. Delta E is the change in EMF, delta T is change in temperature. So delta E divided by delta T is the change in EMF with change in temperature. Therefore, the one with least value of delta E by delta T will show very less change in EMF with change in temperature. So it can be used for a wide range of temperature. So out of these options, the one with the least value of delta E by delta T is option 3. Here the value of delta E by delta T is 0.1 into 10 to the power minus 4, which is the least. So correct option is option 3. In 3D series, the metal having the highest standard electrode potential M2 plus 2M, that is reduction potential. The correct option is copper, option 3. The molar conductivity of a conductivity cell filled with 10 moles of 20 milliliter NaCl solution is lambda m1, and that of 20 moles of another identical cell having 80 ml NaCl solution is lambda m2. The conductivities exhibited by these two cells are same. The relationship between lambda m2 and lambda m1 is, now molar conductivity of NaCl solution, let this be lambda m1, is equal to 1000 into conductivity divided by molarity of NaCl solution. Molar conductivity of another NaCl solution, let it be lambda m2, and this is equal to 1000 into specific conductivity divided by molarity. This is the specific conductivity of solution 1 and this is the conductivity of solution 2. Molarity of solution 1 will be equal to number of moles divided by volume of solution in liters. Number of moles is 10 moles divided by volume of solution in liters. Now volume of solution for this is given as 20 milliliter. In liters it will be 0.02 liter. So 10 divided by 0.02. Molarity of the second solution will be number of moles, that is 20, divided by volume of solution in liters. Volume is 80 milliliter. इसको convert करेंगे liters में, then volume will be 0.08 liter. Now rearranging this equation, molar conductivity into molarity of the first solution is equal to 1000 into conductivity. Now solving this, 1000 gets cancelled, so conductivity is equal to molar conductivity divided by 2. Similarly, for the second solution, molar conductivity into molarity of the second solution, that is 20 by 0.08, is equal to 1000 into conductivity of the second solution. Solving this equation, 2 tens are 20, 2 fours are 8, and 10 into 100 is 1000, so 1000 get cancelled. Conductivity is equal to molar conductivity of the second solution divided by 4. Now conductivity of the first solution is equal to conductivity of the second solution. This is given in the question. Then it can be written from equation 1 and from equation 2, it can be written, since left hand side of the equation 1 and 2 are same, right hand side of the equations will also be the same. It can be written that molar conductivity of solution 1 divided by 2 is equal to molar conductivity of solution 2 divided by 4. 2 ones are 2, 2 twos are 4. Therefore, molar conductivity of solution 2 is 2 times the molar conductivity of solution 1. So correct option is option 1. Given below are two statements. Statement 1, for potassium iodide, molar conductivity increases steeply with dilution. Statement 2, for carbonic acid, molar conductivity increases slowly with dilution. In the light of the above statements, choose the correct answer from the option given below. Option 1, both statement 1 and statement 2 are true. Option 2, both statement 1 and statement 2 are false. Option 3, statement 1 is true but statement 2 is false. And option 4, statement 1 is false but statement 2 is true. Statement 1, for potassium iodide, molar conductivity increases steeply with dilution. Potassium iodide is a strong electrolyte. Strong electrolyte means On dissolving, it undergoes complete dissociation. Therefore, its conductivity remains constant with dilution. Its conductivity does not change with dilution. So, statement 1 is wrong. Statement 2. For carbonic acid, that is H2CO3, molar conductivity increases slowly with dilution. Carbonic acid is a weak electrolyte. On dissolving, it undergoes very little dissociation. But when the solution is diluted, then more and more carbonic acid molecules undergo dissociation. So its dissociation increases with dilution and its conductivity also increases with dilution. जो weak electrolytes होते हैं उनकी conductivity increase होती है with dilution because उनका dissociation भी increase होता है with dilution. So statement 2, that is for carbonic acid molar conductivity increases slowly with dilution, is wrong. It does not increase slowly, it increases very fast with dilution. So statement 2 is also wrong. So correct option is option 2. Both statement 1 and 2 are false. Dissociation means Ki dissociates into its ions. Dissociation into ions. Ki in solution is completely dissociated into potassium and iodide ions. And carbonic acid dissociates into H plus and carbonate ions. But this dissociation is very little. Since it is a weak electrolyte, this dissociation is very little, but on dilution, the dissociation increases. So, the conductivity also increases and it increases very fast. Match list 1 with list 2. Now, lead sulfate plus H2O forming lead plus PbO2 plus H2SO4. This is the charging of secondary battery. So 3 matches with 4. H2 plus O2 forming H2O. This is fuel cell. So 4 matches with 3. Zinc and HgO forming ZnO plus Hg. This is primary battery. So 2 matches with 1. Cadmium, nickel hydroxide changing into cadmium oxide and nickel hydroxide. Here oxidation state is plus 3 and here it is plus 2 and water is formed. This is discharging of secondary battery. So correct option is 1 matches with 2, 2 matches with 1 and 3 with 4 and 4 matches with 3. So correct option is option 3. Compound A used as a strong oxidizing agent is amphoteric in nature. It is the part of lead storage batteries. Compound A is PbO2. It acts as cathode in lead storage batteries. Now in this compound, lead oxide. Lead shows 2 oxidation states, that is plus 2 and plus 4, and in this compound the oxidation state shown by lead is plus 4. Now plus 2 oxidation state of lead is more stable than plus 4 oxidation state. The reason behind this is inert pair effect. Electronic configuration of lead is 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p6, 5s2, 4d10, 5p6, 6s2, 4f14, 5d10 and 6p2. 1s2 to 5p6. This is the configuration of xenon. So electronic configuration of lead can also be written as xenon, then 6s2, 4f14, 5d10 and 6p2. Now from the electronic configuration of lead, it can be seen that when lead loses these two 6p electrons and 6s electron, then it shows plus 4 oxidation state. The outermost shell is the 6th shell, and when all the 4 electron, that is 2 electrons from 6s and 2 electrons from 6p participate in bonding, then plus 4 oxidation state is shown. But plus 2 oxidation state is more stable in lead than plus 4 oxidation state. Therefore, lead in plus 4 oxidation state has a tendency to accept 2 electrons and change into plus 2 oxidation state. In this way, it acts as a good oxidizing agent. Now what is the reason behind lead changing from +4 oxidation state to +2, or why is +2 oxidation state in lead more stable than +4 oxidation state? The reason is the 4f electrons and 5d electrons, they have very poor shielding effect, because of which the outer shell electrons, they experience stronger pull from the nucleus. The 4f electrons and 5d electrons have poor shielding effect. They are not able to shield the nuclear charge from the outermost electrons, because of which the outer shell electrons experience a stronger pull from the nucleus. As a result of which the 6s electrons are not lost easily, or they do not tend to participate in bonding, and +2 oxidation state, which is obtained due to the loss of 6p2 electrons, is more stable than +4 oxidation state, which is attained when both 6s2 and 6p2 electrons are lost. So this tendency of 6s electrons, this pair of electrons, to remain inert and not participate in bonding is known as inert pair effect, and this is due to the fact that these electrons experience stronger pull from the nucleus. Given below are two statements. The E0 value for cerium 4 plus ion changing into cerium 3 plus ion is 1.74. That is cerium 4 plus ion accepting one electron and changing into cerium 3 plus ion. The reduction potential value for this is 1.74 volt. Statement 2. Cerium is more stable in cerium 4 plus state than cerium 3 plus state. Now the reduction potential value for cerium 4 plus ion changing into cerium 3 plus ion is 1.74 volt. Reduction potential value is positive, which means cerium has a very high tendency of accepting electron and changing into cerium 3 plus ion. And for the reverse reaction, that is cerium 3 plus ion losing electron and changing into cerium 4 plus ion, the electrode potential value will be minus 1.74, which means that tendency of cerium to lose electron and change from +3 oxidation state to +4 oxidation state is very less as compared to its tendency to accept electron and changing from +4 oxidation state to +3 oxidation state. Therefore, cerium 4 plus ion will always have a tendency to change into cerium ion in +3 oxidation state, or it could be said that cerium is more stable in its +3 oxidation state than in +4 oxidation state. In the light of the above statements, choose the correct answer from the options given below. Both statement 1 and statement 2 are correct. Statement 1 is incorrect, but statement 2 is correct. Both statement 1 and 2 are incorrect. Statement 1 is correct, but statement 2 is incorrect. Option 4 is the correct option. Statement 1 is correct, that is the reduction potential value of cerium 4 plus ion is 1.74 volt. And statement 2 is incorrect, that is cerium is more stable in +4 oxidation state than in +3 oxidation state. This statement is wrong because cerium is more stable in its +3 oxidation state than in +4 oxidation state. Given below are two statements. Statement 1. The limiting molar conductivity of KCl, strong electrolyte, is higher compared to that of acetic acid, that is weak electrolyte. This statement is wrong. The limiting molar conductivity of acetic acid is higher than KCl. Limiting molar conductivity means conductivity at infinite dilution. Now KCl is a strong electrolyte. It is always 100% dissociated no matter what its concentration is or what is the dilution. So its conductivity is constant. It does not change with dilution. Acetic acid is a weak electrolyte. When it is dissolved in a solvent, its dissociation is very less, but on increasing the dilution, means on adding more solvent to the solution, the dissociation of acetic acid increases and its conductivity also increases. And at infinite dilution, the conductivity of acetic acid is greater than conductivity of KCl. Statement 2. Molar conductivity decreases with decrease in concentration of electrolyte. This statement is also wrong. The reason is, when a weak electrolyte is dissolved in a solvent, then on dilution the conductivity increases. Dilution increases, conductivity increases. But on increasing the dilution, the concentration of electrolyte in the solution decreases. When dilution increases, means if a certain amount of solute is dissolved in a solvent, and if more and more solvent is added to the solution, that is, dilution is increased, the concentration of the electrolyte in the solution will decrease, but the conductivity will increase. For example, if 2 gram of any weak electrolyte is dissolved in 1 liter of solvent, so concentration of the solution is 2 gram per liter. Now, if some more solvent is added to the solution, for example, again 1 liter of the solvent is added to this solution, then total volume of the solution becomes 1 plus 1, 2 liter. Total volume of the solution becomes 1 plus 1, 2 liter, but amount of the solute present or the electrolyte present in this 2 liter of solution is 2 gram. So dilution has increased. Amount of solution is 2 gram. So now the concentration of this solution is 2 divided by 2, that is 1 gram per liter. Weight of solute divided by volume of solution. So this is the strength of the solution. So what has happened, on increasing the dilution, the concentration of the electrolyte in the solution has decreased, but the conductivity increases because on dilution the ionization of the weak electrolyte increases. More and more electrolyte ionizes into its ions, and due to the formation of ions, conductivity increases. So statement 2 is also incorrect. In the light of the above statements, choose the most appropriate answer from the options given below. First, statement 1 is false but statement 2 is true. Second, both statement 1 and statement 2 are true. Third, both statement 1 and statement 2 are false. Fourth, statement 1 is true but statement 2 is false. Now option 3 is the correct option. Both statement 1 and statement 2 are false. Match list 1 with list 2. Degree of dissociation of electrolyte, it will be dimensionless quantity. Then cell constant is L by A. So if L is in centimeter, A is in centimeter square, then cell constant becomes centimeter raised to the power minus 1. Or if it is meter, then meter raised to the power minus 1. तो ये हो जाएगा cell constant matches with 3, A3D2. Then conductivity is per ohm per meter, so C matches with 4. And what is left? Molar conductivity. So molar conductivity B matches with 1. So correct option is option 3. Conductance of NaCl and BaSO4 is C1 and C2 at temperature T1. Then which of the following statement is correct, where T2 is greater than T1? NaCl is a strong electrolyte. It is completely dissociated at all concentrations. And BaSO4 is a weak salt, and its degree of dissociation is less, means it dissociates to a little extent in comparison to NaCl. So number of ions in case of NaCl is greater than that of BaSO4 for a given concentration, because it is completely dissociated and it is dissociated to a very less extent. Therefore C1 will be greater than C2. Option 1 is correct option. The titration curve of a weak acid versus a strong base with phenolphthalein as indicator is shown below. The equilibrium constant for phenolphthalein is 4 into 10 to the power minus 10, log 2 is 0.3. The number of following statement or statements which is or are correct about phenolphthalein is. Pehla statement, it can be used as an indicator for the titration of weak acid with weak base. Wrong. It is used in titration for weak acid with a strong base. Next is, it begins to change color at pH 8.4. Now, constant for indicator is given as 4 into 10 to the power minus 10. So, pK indicator will be equal to minus log of 4 into 10 to the power minus 10, and this can be written as log 1 by 4 into 10 to the power minus 10, or log of 10 to the power 10 divided by 4. This can be written as log 10 to the power 10 minus log 4. log 4 को क्या लिख सकते हैं? log 2 square. log 10 to the power 10 को लिख सकते हैं 10 log 10. 10 log 10 is 10 minus log 2 square हो जाएगा 2 log 2. तो सॉल्विंग ये हो गया 2 into log 2 हो गया 0.3. सो 10 minus 0.6, तो इसकी वैल्यू आ जाएगी 9.4. नाउ कोई भी इंडिकेटर, इफ दिस इज इंडिकेटर, देन ये इक्विलिब्रियम आ जाती है इंडिकेटर की, डिसोसिएट्स इनटू इट्स आयंस. अनडिसोसिएटेड इंडिकेटर, सपोज इट हैज कलर A, एंड व्हेन द इंडिकेटर डिसोसिएट्स इनटू इट्स आयंस, तो इसका कलर, आयन का कलर हो गया सपोज कलर B. तो डिसोसिएटेड फॉर्म में इट शोज कलर B एंड अनडिसोसिएटेड फॉर्म कलर A. तो कलर चेंज, नाउ दिस कलर चेंज टेक्स प्लेस एट अ सर्टेन pH. अब अगर इस इक्वेशन का इक्विलिब्रियम कांस्टेंट निकालेंगे तो K इंडिकेटर विल बी इक्वल टू प्रोडक्ट ऑफ द कॉन्सेंट्रेशन ऑफ द प्रोडक्ट डिवाइडेड बाय कॉन्सेंट्रेशन ऑफ द रिएक्टेंट. ये इक्विलिब्रियम कांस्टेंट है. नाउ एट द मिड पॉइंट ऑफ द कलर रेंज ऑफ इंडिकेटर, जो भी इंडिकेटर का कलर रेंज है, एट द मिड पॉइंट ऑफ इट, concentration of the indicator ion is equal to concentration of the undissociated indicator. So in this equilibrium, concentration of indicator and the concentration of the remaining indicator, that is undissociated indicator, will cancel, and K indicator will be equal to the concentration of H plus ions. तो K indicator H plus ion concentration के बराबर हो गई. तो pK indicator will be equal to pH. So pK indicator will give the pH at which the color change may take place. तो यहाँ पे pK indicator की वैल्यू क्या आई है? pK indicator की वैल्यू आई है 9.4. So pH at which the color change may take place is 9.4, and the range will be plus minus 1. 9.4 means 9.4 minus 1 हो गया 8.4, एंड 9.4 प्लस 1 हो गया 10.4. तो इस रेंज में फिनोल्फथलीन का कलर चेंज होगा. सो इट बिगिंस टू चेंज कलर एट pH 8.4. स्टेटमेंट इज करेक्ट. इट इज अ वीक ऑर्गेनिक बेस. रॉन्ग. इट इज अ वीक ऑर्गेनिक एसिड. इट इज कलरलेस इन एसिडिक मीडियम. करेक्ट. इट इज कलरलेस इन एसिडिक मीडियम. So how many statements are correct here? The number of statements correct here are 2. So answer is 2. The number of incorrect statement from the following is: the electrical work that a reaction can perform at constant pressure and temperature is equal to the Gibbs energy. Correct. E naught cell is dependent on the pressure. Correct. dE by dt is equal to delta S by NF. Delta G is equal to minus NFE naught. D delta G naught by dt is equal to minus delta S. Putting the value of delta G, D minus NFE naught by dt is equal to minus delta S. This can be written as minus NF dE by dt is equal to minus delta S naught. So dE by dt is equal to minus minus gets cancelled, delta S by NF. So this statement is also correct. A cell is operating reversibly if the cell potential is exactly balanced by an opposing source of potential difference. This statement is wrong. A cell is operating reversibly if the cell potential is exactly balanced by an opposing source of potential difference. Means the cell potential is equal to the external source of potential difference. A cell operates reversibly when external source of potential difference is greater than the cell potential, not equal to the cell potential, but the external source of potential difference is greater than the cell potential. Under this condition, the cell will operate reversibly. So number of incorrect statements from the following is 1. Out of 4, 1 statement is incorrect. Question. The number of correct statements from the following is: E cell is an intensive parameter. Correct. Intensive parameter means it does not depend upon the quantity of the substance. So E cell is an intensive parameter. B. A negative E naught means that the redox couple is a stronger reducing agent than the H plus H2 couple. This statement is also correct. The reduction potential of hydrogen electrode is 0, that is H plus changing to hydrogen gas, reduction potential is 0. And if any metal ion accepting electrons and changing into metal atom, the reduction potential of the metal ion, if it is negative, then the tendency of the metal ion to accept electron and change into metal atom is less than hydrogen. So in the case of this metal, it will tend to lose electron and change into cation, and it will act as a reducing agent. Since the tendency to lose electron is greater than tendency to accept electron, it will act as a reducing agent. Any metal which has tendency to accept electron will act as oxidizing agent, and the one which has greater tendency to lose electron will act as reducing agent. This metal has a greater tendency to lose electron in comparison to hydrogen, so it will act as a reducing agent. So this statement is also correct. Statement C. The amount of electricity required for oxidation or reduction depends on the stoichiometry of the electrode reaction. Correct. This statement is also correct. During oxidation or reduction, electrons are lost or gained, and in a balanced equation, the number of moles of electron will decide the charge, and in turn it will decide the amount of current carried. For example, in this reaction, the moles of electron involved is 2. So 2 moles of electron means what is the charge? 1 mole of electron means 96500 coulombs of charge. So 2 moles of electron means 2 into 96500 coulombs of charge, and 96500 coulombs is also known as 1 Faraday. So 1 mole of electron means 1 Faraday of electricity, and 2 moles of electron means 2 Faradays of electricity. So whatever is the stoichiometric coefficient of the electron in the balanced reaction, it will decide the amount of electricity. Now option D, the amount of chemical reaction which occurs at any electrode during electrolysis by a current is proportional to the quantity of electricity passed through the electrolyte. Correct. Again, whatever reaction takes place at the electrode, it involves loss of electron or gain of electron. Electron carries charge. This charge in turn depends upon the quantity of electricity that is passed through the electrolyte. So this statement is also correct. Therefore, the number of correct statements from the following is: total number of correct statements is 4. So answer is 4. Following figure shows dependence of molar conductance of two electrolytes on concentration. Lambda m is the limiting molar conductivity. The number of incorrect statements from the following is: lambda m for electrolyte A is obtained by extrapolation. This statement is wrong. The curve of A is parallel to the y-axis, so lambda m for electrolyte A will not be obtained by extrapolation. On the other hand, lambda m for B can be obtained by extrapolation. Second, for electrolyte B, lambda m versus square root of C graph is a straight line with intercept equal to lambda m. Correct? The graph of B is a straight line and the intercept will be equal to lambda m. At infinite dilution, the value of degree of dissociation approaches 0 for electrolyte B. Again, this statement is wrong. B is a strong electrolyte. At infinite dilution, the degree of dissociation of B is not 0. D. Lambda m for any electrolyte A or B can be calculated using lambda naught for individual ions. Correct? Applying Kohlrausch's law, if lambda m for NaCl has to be calculated, then lambda naught for Na plus ion plus lambda naught for Cl minus ion will give lambda naught for NaCl. And using this, the conductivity at a given concentration can be calculated. So statement A is wrong, statement C is wrong, statement B is correct, statement D is correct. So number of incorrect statements from the following is 2. Consider the reaction H2SO3 aqueous plus SN4 plus aqueous plus H2O liquid forming SN2 plus aqueous plus HSO4 minus aqueous and 3H plus. Which one of the following statements is correct? First, SN4 plus is the oxidizing agent because it undergoes oxidation. SN4 plus is changing to SN2 plus. तो इसका ऑक्सीडेशन स्टेट चेंज हो रहा है +4 से +2 में. Now to change the oxidation state from +4 to +2, electron has to be added. Means SN4 plus will accept 2 electrons and then it will change into SN2 plus. So this is not oxidation, this is reduction. Therefore, SN4 plus is oxidizing agent. This part of the statement is correct because it is electron acceptor. But SN4 plus is oxidizing agent because it undergoes oxidation is wrong. This part of the statement is wrong. It is not undergoing oxidation, it is undergoing reduction. Second, SN4 plus is the reducing agent because it undergoes oxidation, wrong. SN4 plus is not reducing agent, it is the oxidizing agent because it is undergoing reduction itself. H2SO3 is the reducing agent because it undergoes oxidation. Now for that, in H2SO3 the oxidation state of sulfur will be, let it be Y. So oxidation state of hydrogen is +1. So 2 into +1 plus number of sulfur atoms is 1. So 1 into Y plus number of oxygen atoms is 3 and oxidation state of oxygen is -2. This is equal to 0. So 2 plus Y minus 6 is equal to 0. Therefore Y is equal to 6 minus 2, that is 4. So oxidation state of sulfur in H2SO3 is +4 and oxidation state of sulfur in HSO4 minus, number of hydrogen atoms in HSO4 is 1. So 1 into +1. +1 is the oxidation state of hydrogen. Let the oxidation state of sulfur be Y. Number of sulfur atoms is 1. So 1 into Y plus number of oxygen atoms is 4. So 4 into oxidation state of each oxygen atom is -2. This is equal to total charge on this ion is -1. Solving, this is 1 plus Y minus 8 is equal to -1. So Y is equal to -1 plus 8 minus 1, which is equal to +6. So here the oxidation state of sulfur in HSO4 minus is +6. So oxidation state of sulfur changes from +4 to +6. It is +4 in H2SO3 and +6 in HSO4 minus, which means that H2SO3 is losing 2 electrons and it is changing into HSO4 minus. So it is getting oxidized. This reaction is oxidation reaction. It is getting oxidized and it is acting as a reducing agent. Here sulfur is getting oxidized from +4 to +6. Therefore H2SO3 is acting as a reducing agent. So statement 3 is correct. H2SO3 is the reducing agent because it undergoes reduction. This statement is wrong. H2SO3 is the reducing agent not because it undergoes reduction. It is reducing agent because it undergoes oxidation. So this part of the statement is wrong. So the correct statement is statement 3. Which one of the following cannot function as an oxidizing agent? Option 1, iodide ion. Iodide ion cannot function as an oxidizing agent. The decreasing order of electrical conductivity of the following aqueous solution is 0.1 m formic acid, 0.1 m acetic acid and 0.1 m benzoic acid. Now formic acid is a stronger acid than benzoic acid and benzoic acid is a stronger acid than acetic acid. So greater is the acidic strength, greater is the tendency to undergo ionization and give H plus ions, and greater is the number of ions, greater is the conductivity. Therefore, electrical conductivity of formic acid is greater than the electrical conductivity of benzoic acid, which is in turn greater than electrical conductivity of acetic acid. So correct order is option 1, A greater than C, C greater than B. Question: resistance of 0.2 m solution of an electrolyte is 50 ohm. The specific conductance, it is also known as conductivity, of the solution is 1.4 per ohm per meter. The resistance of 0.5 m solution of the same electrolyte is 280 ohm. The molar conductivity of 0.5 m solution of the electrolyte in per ohm meter square per mole is. Concentration of electrolyte solution is 0.2 moles per liter. Resistance is given as 50 ohm. And the conductivity or specific conductance of the solution is given as 1.4 per ohm per meter. From this, cell constant of the cell can be calculated. Cell constant is equal to specific conductance multiplied by resistance. So this is equal to 1.4 into 50. This can be written as 14 divided by 10. 0, 0 cancels. 14 5s are 70. So this is 70 per meter. This is the cell constant. Now in the same cell, same electrolyte is taken, but this time the concentration is different. It is 0.5 moles per liter. And the resistance is 280 ohm. Cell constant will be 70 per meter because the cell is the same conductivity cell is used. Molar conductivity has to be calculated. What is the formula for molar conductivity? Molar conductivity is equal to conductivity divided by concentration. Conductivity is equal to cell constant divided by resistance. Cell constant is 70 per meter. Resistance is, for the second electrolytic solution, the resistance is 280 ohm. Solving, 0, 0 cancels, 7 1s are 7, 7 4s are 28. This is 1 by 4. 1 by 4 per ohm per meter. This is the specific conductivity of the second electrolyte solution. Now concentration of the second electrolyte solution is given in moles per liter, but here the unit of length in specific conductivity is per meter. So concentration has to be changed from moles per liter to moles per meter cube. What is the conversion factor? 1 meter cube is equal to 1000 liter, or it can be written as 1000 liter per meter cube. Therefore, the concentration which is given here as 0.5 moles per liter, if it is multiplied by 1000 liter per meter cube, then liter cancels and this becomes 0.5 into 1000 moles per meter cube. Now the unit of length in specific conductance and molarity is same. Therefore, molar conductance is equal to specific conductance into 1 by concentration of the solution. This is equal to 1 by 4 into 1 divided by 0.5 into 1000. Solving this, the value of molar conductivity is 5 into 10 to the power minus 4 per ohm meter square per mole. This is the unit in which the molar conductivity is asked. So correct option is option 1. Given reduction potential values are given. Among the following, the strongest reducing agent is. Now in this question, all these values are reduction potential values, as can be seen. Chlorine changing into chloride, and this is reduction. Chromium from +3 oxidation state changing to 0 oxidation state. This is also reduction. Cr2O72 minus 2 Cr3 plus. This is also reduction, because in Cr2O72 minus, the oxidation state of each chromium atom is +6. So +6 to +3 is reduction. Then MnO4 minus 2 Mn2 plus. This is again reduction. In MnO4 minus, manganese is in +7 oxidation state. From +7 to +2 is reduction. These numerical values are the reduction potential values. So just writing the reverse reaction, that is chloride to chlorine. Here oxidation state changes from -1 to 0, means this is oxidation, and the value of oxidation potential, the numerical value will remain the same as the reduction potential value, but the sign will change. For example, the reduction potential value was +1.36, oxidation potential value is -1.36. Similarly, for chromium, the oxidation potential value is 0 to +3, oxidation is taking place, plus 0.74. Just the sign will change. The reduction potential value is -0.74 volt. For oxidation potential value, it will be plus 0.74 volt. Numerical value remains the same and the sign changes. Chromium from +3 to +6, again oxidation potential value is -1.33. Manganese from +2 to +7, again oxidation potential value is -1.51 volt. So out of this, the maximum oxidation potential value is for chromium to chromium +3 state, that is plus 0.74. This is the maximum oxidation potential value. The one with maximum oxidation potential value will have the maximum tendency to get oxidized, or it will act as the strongest reducing agent. So the strongest reducing agent is chromium. So option 1 is the correct option. Chromium has the highest oxidation potential value, so its tendency to lose electron and change into chromium ion in +3 oxidation state. And how many electron it is losing? 3 electrons is high. Its tendency to lose electron is high, so it acts as a strong reducing agent, since it has a high tendency to lose electron and change into chromium ion in +3 oxidation state. Question: the equivalent conductances of two strong electrolytes at infinite dilution in water, means solvent is water, where ions move freely through a solution at 25 degrees centigrade are given below. For sodium acetate 91, for HCl 426.2. What additional information or quantity one needs to calculate limiting molar conductivity of an aqueous solution of acetic acid? This is the symbol for limiting molar conductivity. Limiting molar conductivity of HCl will be equal to conductivity of H plus ions plus conductivity of chloride ions at infinite dilution, and limiting molar conductivity of sodium acetate is equal to conductivity of acetate ion plus conductivity of sodium ions. On adding these two, these are the conductivities at infinite dilution, molar conductivity at infinite dilution. On left hand side of the equation we get limiting molar conductivity of HCl plus limiting molar conductivity of sodium acetate is equal to conductivity of H plus ion plus limiting molar conductivity of acetate ion plus limiting molar conductivity of Cl minus ion plus limiting molar conductivity of sodium ions. Now for limiting molar conductivity of acetic acid, what is needed is conductivity of acetate ion at infinite dilution plus conductivity of H plus ion at infinite dilution. From this equation, if conductivity of NaCl is subtracted from both sides, subtracting the limiting molar conductivity of NaCl, on this side it will be conductivity of Na plus ions and conductivity of Cl minus ions at infinite dilution. So on subtracting the limiting molar conductivity of NaCl on both the sides of this equation, conductivity of chloride ions is cancelled, conductivity of sodium ions is cancelled, and conductivity of H plus and acetate ions at infinite dilution, this is equal to limiting molar conductivity of acetic acid. As can be seen, what has to be subtracted from the conductivity values? The limiting molar conductivity of NaCl. So to get the limiting molar conductivity of acetic acid, limiting molar conductivity of NaCl has to be subtracted. So option 2 is the correct option. Question: a current of 10 ampere flows for 2 hours through an electrolytic cell containing a molten salt of metal X. The result in the decomposition of 0.250 mole of metal X at the cathode. यहाँ पे this result in the decomposition of 0.250 mole of metal X at the cathode. The oxidation state of X in the molten salt is 1 Faraday is equal to 96500 coulomb. Current की value given है 10 ampere. Time for which the current flows is 2 hours. This is equal to 2 into 60 into 60 seconds. And what amount of the metal decomposes at cathode? Moles of the metal. Moles of metal is equal to 0.250 moles. Weight of the substance deposited at the electrode or weight of the metal deposited at the cathode is equal to equivalent weight of the metal multiplied by current multiplied by time for which current is flowing divided by 96500 coulomb. And equivalent weight of the metal will be equal to atomic mass of the metal, atomic mass of the metal divided by the valency factor or the oxidation state of the metal. Let the oxidation state of the metal be Z. So this formula, let it be 1, becomes W is equal to atomic mass, let it be M. So this becomes M into I into T divided by Z. Therefore, Z is equal to, this is the oxidation state that we have to find out. So Z is equal to M into I into T divided by W, weight of the metal deposited. Now atomic mass divided by weight. Number of moles is equal to weight divided by atomic weight. Now atomic weight divided by weight will be equal to, see, 1 by N will be equal to atomic weight divided by weight. So this is equal to 1 by N into I into T. Now putting the values, this is 1 by 0.250 multiplied by, what is the value of current? Value of current is 10 ampere multiplied by time. Time in seconds will be this is divided by 96500 coulombs. Here 96500 coulomb in the denominator. Here also 96500 coulomb in the denominator, and here also 96500 coulomb in the denominator. So 10 into 2 into 60 into 60. Solving, this is equal to 2.98, or approximately this is equal to 3. So oxidation state of the metal, since it is a metal, it will be plus 3. So option 3 is the correct answer. Question: when the sample of copper with zinc impurity is to be purified by electrolysis, the appropriate electrodes are. This is just refining, making use of electrolysis. So anode is made up of the impure metal. So copper with impurity of zinc will be the anode, and anode is thick, and cathode is made up of pure metal, and cathode is thin. And electrolyte usually contains the ion of the metal which has to be purified. So what happens during this electro-refining is copper from the solution, that is Cu2 plus from the solution, will go to the cathode. It will accept electron and it will be deposited on the cathode. On the other hand, copper from anode will go into the solution as Cu2 plus ions. So slowly what happens, the whatever copper is present at the anode will be deposited at the cathode, and the impurities will be left behind as anode mud. So copper from anode will get deposited at the cathode, and impurities present in the copper will be deposited below the anode as anode mud. So correct option is pure copper as cathode and impure sample as anode. So the correct option is option 4. The standard EMF of a cell involving one electron charge is found to be 0.591 volt at 25 degrees centigrade. The equilibrium constant of the reaction is. Value of Faraday constant is given as 96500 coulomb per mole. Value of R 8.314 joule per Kelvin per mole. What is given? E naught cell is given, and E naught cell is equal to 0.591 volt. Faraday's constant value is given. Value of gas constant is given. Formula to be used: E cell is equal to E naught cell minus 0.0591 by N log K. Here K is the equilibrium constant. Now at equilibrium, E cell will be 0. So this equation becomes E naught cell is equal to 0.0591 by N log K. Now putting the values, E naught cell की value क्या given है? E naught cell की value given है 0.591 is equal to 0.0591. अब क्वेश्चन में ये भी गिवन है कि involving one electron change, means the electron change means electron given or electron accepted is 1, number of electrons given or number of electron accepted is 1. So यहाँ पे n की वैल्यू मतलब number of electrons की वैल्यू हो जाएगी 1 log k. Solving, log k की वैल्यू हो जाएगी 0.591 divided by 0.0591, and this is equal to 10. Now to find the value of k, k is equal to anti-log 10, which is equal to 10 to the power 10. So this is the value of equilibrium constant. 10 to the power 10, it can also be written as 1.0 into 10 to the power 10. So correct option is option 1. Identify the correct statement. Corrosion of iron can be minimized by forming a contact with another metal with a higher reduction potential. No. Iron corrodes in oxygen-free water. No. Iron needs both oxygen and moisture for corrosion. Corrosion of iron can be minimized by forming an impermeable barrier at its surface. Correct. Iron corrodes more rapidly in salt water because its electrochemical potential is higher. Wrong. So correct option is option 3. In a hydrogen-oxygen fuel cell, combustion of hydrogen occurs to: first, produce high purity water; second, create potential difference between two electrodes; third, generate heat; fourth, remove adsorbed oxygen from electrode surfaces. First of all, what is fuel cell? Fuel cell is actually a kind of galvanic cell which is designed in such a way so that whatever energy is produced during combustion of fuels like hydrogen, methane will be changed into electrical energy. Now in hydrogen-oxygen fuel cell, the fuel is hydrogen and porous carbon electrodes are used. Platinum or palladium is used as catalyst. The electrodes are coated with this platinum or palladium powder which act as catalyst, and the electrolyte used is concentrated aqueous solution of NaOH. The reaction taking place at the cathode: oxygen plus H2O forming OH minus ion. Balancing, this is 2H2O, this is 4OH minus ion. 4 units of negative charge on the product side. OH minus has, each OH minus ion has 1 unit of negative charge. So 4 into OH minus ions means 4 unit of negative charge. So 4 units of negative charge on the product side to balance 4 electrons on the reactant side will be added. So this is the reduction reaction which is taking place. Oxygen has oxidation state of 0. And in OH minus ion, oxidation state of oxygen will be -2. So reduction of oxygen is taking place. And reaction taking place at anode: hydrogen plus OH minus ion forming H2O. Again, to balance the equation, this will be 4H2O and here it will be 2 OH minus ions, and here it will be 4 OH minus ions and 2 H2. Now again 4 units of negative charge on the reactant side. To balance the negative charge, 4 electrons will be added on the product side. So this is oxidation reaction. Hydrogen has oxidation state of 0 and in the product water is formed, and in water hydrogen has oxidation state of +1. So this is oxidation reaction. Now during the reaction at the anode, electrons are produced at the anode and these electrons go from anode to cathode in the external circuit, as a result of which current flows in the external circuit in the direction opposite to the direction of flow of electrons, and this flow of electrons also creates a potential difference between two electrodes. So the correct option is, in a hydrogen-oxygen fuel cell, combustion of hydrogen occurs to create potential difference between two electrodes. Option 2 is the correct option. The reaction at the anode, the balanced reaction at the anode is H2 plus 2 OH minus ion forming 2H2O. Now in this case, there are 2 units of negative charge on the reactant side, and to balance the 2 units of negative charge, there will be 2 electrons added on the product side. But the reaction at the cathode, the number of electrons on the reactant side is 4. So in order to add these reduction and oxidation reaction, the number of electrons have to be the same. So multiplying this whole equation by 2, the final equation is 2H2 plus 4OH minus forming 4H2O plus 4 electrons. Now number of electrons gained is equal to number of electrons lost. Adding the reaction at cathode and anode, 4OH minus ion will cancel, 4 electrons and 4 electrons will get cancelled. 4H2O minus 2H2O will be equal to 2H2O. So overall reaction which is taking place is 2H2 plus O2 forming 2H2O. So hydrogen is acting as a fuel which is undergoing combustion. The energy which is produced during this combustion is getting converted into electricity. And this flow of electricity is due to the flow of electrons from anode to cathode in the external circuit. 1 Faraday of electricity liberates X into 10 to the power minus 1 gram atom of copper from copper sulfate. X is, first of all, what is gram atom? 1 gram atom is the weight of one atom in grams. Weight of one atom of an element in grams is called gram atom. So this can be written as equal to atomic weight. Now atomic weight is also equal to 1 mole. So 1 gram atom can be said to be equal to 1 mole of the substance. So according to this question, 1 Faraday of electricity liberates X into 10 to the power minus 1 moles of copper atom. 1 Faraday is liberating X into 10 to the power minus 1 mole of copper atom. You have to find out the value of X. First of all, write the reaction. Here in copper sulfate, copper is present as Cu2 plus ion. So when copper is liberated, Cu2 plus ion accepts 2 moles of electron and it changes to copper atom. According to this balanced equation, moles of copper ion is 1, moles of electron is 2 and moles of copper liberated is 1. So 1 mole of copper atom is liberated from 2 moles of electron. To deposit 1 mole of copper, 2 moles of electron are required. Now charge carried by 1 mole of electrons is also known as 1 Faraday. So charge carried by 2 moles of electron will be equal to 2 Faraday. So 2 Faradays of electricity is depositing 1 mole of copper atom. Therefore 1 Faraday of electricity will deposit 1 by 2 mole of copper atom. 1 by 2 moles means it can be written as 0.5 mole, or this is also equal to 5 into 10 to the power minus 1 mole. So here the value of X is 5. So answer is 5. 0.05 centimeter thick coating of silver is deposited on a plate of 0.05 meter square area. The number of silver atoms deposited on plate are dash into 10 to the power 23. Thickness of silver coating is given, area of the plate is given, and atomic mass of silver is given, density of silver is given. तो वॉल्यूम क्या हो जाएगा? वॉल्यूम हो जाएगा एरिया इंटू थिकनेस. अब एरिया गिवन है 0.05 मीटर स्क्वायर और थिकनेस गिवन है 0.05 सेंटीमीटर. तो सबसे पहले तो मीटर स्क्वायर को कन्वर्ट करेंगे सेंटीमीटर स्क्वायर में. सो दिस इज इक्वल टू 0.05. अब मीटर स्क्वायर कैसे लिख सकते हैं? मीटर इंटू मीटर. 1 मीटर इज इक्वल टू 100 सेंटीमीटर. So this can be written as 0.05 into 100 सेंटीमीटर. इस मीटर को कन्वर्ट किया सेंटीमीटर में. Now this meter, converting this into centimeter, this becomes 100 centimeter. So this is equal to 500 centimeter square. So volume will be equal to area into thickness. Thickness given है 0.05. And this will be equal to 25 centimeter cube. This is the volume of silver deposited. अब volume of silver पता है, density of silver पता है. So mass of silver will be equal to, now mass by volume is equal to density, therefore mass will be equal to volume into density. So mass of silver will be equal to 25 into Density of silver, that is 7.9 gram per centimeter cube. This is equal to 197.5 gram. This is the mass of silver. Once you know the mass of silver, you can calculate the moles of silver. Moles of silver atoms is equal to weight divided by atomic weight. So 197.5 divided by atomic weight of silver, that is 108 gram per mole. Number of atoms. Number of atoms of silver is equal to moles of silver multiplied by Avogadro number. Why multiplying with Avogadro number? 1 mole of any substance contains Avogadro number of particles. N moles of any substance will contain N into Avogadro number of particles. So moles of silver multiplied by Avogadro number, this is equal to 197.5 divided by 108 multiplied by 6.022 into 10 to the power 23. Number of atoms of silver will be 11 into 10 to the power 23. In the fill in the blanks, the answer is 11. The standard reduction potential at 298 Kelvin for the following half cells are given below. The number of metals which will be oxidized by nitrate in aqueous solution is. Standard reduction potential of nitrate, V2 plus ion, Fe3 plus ion, silver ion and gold ion are given. You have to find the number of metals which will be oxidized by nitrate. Now any species whose reduction potential value is high, it acts as a good oxidizing agent. It acts as a good oxidizing agent because its tendency to accept electron is high. If you compare the reduction potential values of the nitrate with other elements, the reduction potential value of nitrate is greater than vanadium, iron and silver. Since reduction potential value of nitrate is greater than vanadium, iron and silver ions, its tendency to get reduced is greater in comparison to these ions. In other words, when nitrate is present with vanadium, it will oxidize vanadium to vanadium ion. When nitrate is present with iron, it will oxidize iron to Fe3 plus ion. And when nitrate is present with silver, it will oxidize silver to silver ion. Because the tendency of nitrate ion to get reduced is greater than vanadium, iron and silver. So the number of metals which will be oxidized by nitrate in aqueous solution is 3. 3 metals will be oxidized by nitrate ion in aqueous solution. But what happens when nitrate and gold ion both are present in solution? Now since the reduction potential value of gold is greater than nitrate, here it can be seen that the reduction potential value of gold is greater than the nitrate. So here gold will not be oxidized by nitrate ion. In this question, the electrode potential value when FeO4 2- changes to Fe2 plus has to be calculated. Now in the question it is given as the electrode potential value is x into 10 to the power -3 volt. Value of x has to be calculated. And individual steps electrode potential values are given. So FeO4 2- changing to Fe3 plus and Fe3 plus changing to Fe2 plus, Fe2 plus changing to Fe. Now delta G value for all individual steps can be added. So delta G1 is the value of delta G for FeO4 2- to Fe3 plus. This is delta G1. For the step Fe3 plus to Fe2 plus, the value of delta G is delta G0 2. And the overall step, that is FeO4 2- changing to Fe2 plus, let the value of delta G be delta naught G. So delta naught G can be written as, means delta naught G for the overall conversion of FeO4 2- to Fe2 plus will be equal to delta G01 plus delta G02. That is sum of the individual steps. Now delta G is equal to minus NFE. So putting the value of delta G naught minus NF E naught is equal to minus N1 F E naught 1 plus minus N2 F E naught 2. This becomes minus N1 F E naught 1 minus N2 F E naught 2. F will get cancelled. What is N? N is the number of electrons involved in the redox reaction. To find the value of N, first you have to calculate the oxidation state of iron in FeO4 2-. For that, assume that the oxidation state of iron in FeO4 2- is Z. Oxidation state of oxygen is -2. Number of atoms of oxygen is 4. So, and overall charge on FeO4 is 2-. So, Z, oxidation state of iron, plus total oxidation state of the 4 oxygen atoms present will be equal to 4 into -2 is equal to overall charge on this complex anion, that is -2. This will be equal to Z minus 8 is equal to -2. So Z is equal to -2 plus 8, which is equal to 6. So oxidation state of iron in FeO4 2- is +6. From +6 it is changing to +3 in step 1. So the number of electrons involved in step 1, that is the value of N1, will be equal to 3 and E01 is given as 2.2. Similarly in step 2, this is step 1 and this is step 2. In step 2, Fe3 plus is changing to Fe2 plus. So change in oxidation number is from +3 to +2. So change in oxidation number is 3 minus 2, that is 1. In the first step, change in oxidation number is from +6 to +3. So change was, N1 was 6 minus 3, that is 3. In the second step, +3 to +2, change is 3 minus 2, 1. So value of N2 is 1. E2 is given as 0.70. And what is the value of N? N is the number of electrons involved when FeO4 2- changes to Fe2 plus, means sum of step 1 and step 2. So in FeO4 2- it is +6, Fe2 plus it is +2. So change is, value of N will be 6 minus 2, that is 4. Value of N is 4. E0 you have to find out. So 4 minus 4 into E0 is equal to minus 3 into 2.2, 6.6, minus 1 into 0.70 is 0.70. Solving, E0 is equal to minus 6.6 minus 0.70 is equal to minus 7.30 divided by minus 4. Minus minus cancelled. E0 is equal to 1.825 volt, or it can also be written as 1825 into 10 to the power minus 3 volt. So x into 10 to the power minus 3 volt, the value of x is 1825. The specific conductance of 0.0025 m acetic acid is 5 into 10 to the power minus 5 per ohm per centimeter at a certain temperature. The dissociation constant of acetic acid is dash into 10 to the power minus 7. Consider limiting molar conductivity of acetic acid as 400 per ohm centimeter square per mole. Now formula is molar conductance is equal to specific conductance multiplied by volume of solution in centimeter cube containing 1 mole of the electrolyte. This is the formula. Now molarity of the solution is given as 0.0025 moles per liter. 1 liter is equal to 1000 centimeter cube. तो molarity है 0.0025 moles per liter. It can be said that in 1 liter 0.0025 moles of electrolyte is present, or it can also be said that 0.0025 moles of electrolyte is present in 1000 centimeter cube of the solution. Therefore, 1 mole of electrolyte is present in 1000 divided by 0.0025 centimeter cube of solution. So, putting the values in the formula for the molar conductivity is equal to specific conductance, that is 5 into 10 to the power minus 5 multiplied by volume of solution containing 1 mole of electrolyte. Now the volume of solution containing 1 mole of electrolyte is 1000 divided by 0.0025 centimeter cube. Now see, the unit of length in the value of specific conductance is centimeter, and the unit of length in volume of solution is also centimeter. So the reason behind converting the unit of volume from liter to centimeter cube is specific conductance. In specific conductance, the unit of length is in centimeter. Solving molar conductivity value is 20. Alpha is equal to molar conductivity at a given concentration divided by limiting molar conductivity. So this is equal to 20 divided by 400, which is equal to 1 by 20. Now equation for the dissociation of acetic acid is CH3COOH dissociates into CH3COO minus plus H plus. So if the concentration is C moles per liter, then this equation becomes, the concentration of various species in this equation becomes C into 1 minus alpha, C alpha, where alpha is the degree of dissociation. So value of K will be equal to C alpha into C alpha divided by C into 1 minus alpha. C gets cancelled, and putting the values C in the numerator, C that is 0.0025 into alpha square, that is into 1 by 20 into 1 by 20 divided by 1 minus 1 by 20. Solving this equation, the value of equilibrium constant is equal to 66 into 10 to the power minus 7. So here in the fill in the blanks, the value is 66. In an electrochemical cell, reaction of lead at a standard temperature, if this is E naught value of lead 2 plus changing to lead, reduction potential of lead 2 plus is m volt, reduction potential of this will be lead 4 plus is n volt, and the value of E naught from lead 4 plus is given by m minus nx. The value of x is, write the stepwise reduction of lead, that is lead from plus 4 oxidation state changing to plus 2 oxidation state, and from plus 2 to lead. This is stepwise, and one is the direct conversion of lead from plus 4 to lead. Lead from plus 4 to plus 2, E naught value, let it be E naught 1. This you have to find out. Number of electrons involved in this step is 2. Lead from plus 2 to lead. This is given in the question as, the E naught value is given as m volts. Let it be equal to E naught 2. Number of electrons involved in this step is also 2. Lead from plus 2 changing to lead in 0 oxidation state. So total electrons accepted in this step is 2 electrons. Next is lead from plus 4 oxidation state directly changing into lead to 0 oxidation state. Here the number of electrons involved will be 4, and let the E naught value of this step be E naught. Now for step 1, let this be step 1, this is step 2, this is step 2, and this is step 3. So for step 1, delta G value delta G naught 1. For step 2, delta G value is delta G naught 2. And for step 3, delta G value is delta G naught. Number of electrons involved in step 1, N1 is equal to 2 electrons, as lead changes from +4 to +2 oxidation state. So decrease in oxidation state is by 2, so it accepts 2 electrons. For step 2, number of electrons involved is N2, which is equal to 2 electrons. Here lead changes from +2 oxidation state to 0 oxidation state. For step 3, the number of electrons involved is 4, as lead changes from +4 oxidation state to 0 oxidation state, so it accepts 4 electrons. Now writing the expression, delta G naught is equal to delta G naught 1 plus delta G naught 2. The delta G naught value for lead from +4 oxidation state changing to lead, that is for step 3, will be sum of the delta G values of the step 1 and 2. Putting the value of delta G naught, it is equal to minus NF E naught is equal to minus N1F E naught 1 plus minus N2F E naught 2. Simplifying this equation, this becomes, now this can be written as minus NF E naught is equal to minus N1F E naught 1 minus N2F E naught 2. F gets cancelled, and taking the minus sign in common, this becomes minus N E naught is equal to minus N1 E naught 1 plus N2 E naught 2. Minus minus cancels. Now putting the values, value of N is 4 into E naught value for the third step is given as N volts. So 4 into N is equal to value of N1. N1 is equal to 2 into E naught 1, that you have to find out, plus N2 is given as M, E naught 2 plus N2 is given as 2 multiplied by E naught 2, which is M. Rearranging, now taking 2 as common, 2, this is E naught 1 plus M. So 2 2s are 4. So 2N is equal to E naught 1 plus M. So E naught 1 is equal to 2N minus M. Now E naught 1 is the value of EMF when lead in +4 oxidation state is changing into lead in +2 oxidation state. So E naught 1 is equal to 2N minus M. Therefore for the reverse reaction, that is lead in +2 oxidation state, lead in +2 oxidation state changing into lead in +4 oxidation state, this will be equal to the reverse, that is E naught value will be equal to minus 2N minus M, that is M minus 2N. This is from +2 to +4. So in the question the value is given as M minus N into X. So here the value of X will be 2. Value of X is 2. Consider the cell. यहाँ पे एक cell given है. Standard electrode potential of iron is given, that is 0.771 volt. Standard electrode potential of hydrogen electrode is equal to 0 volt, temperature 298 Kelvin. Potential of the cell is 0.712 volt. You have to find the ratio of the concentration of Fe2 plus ion to Fe3 plus ion. E cell given has 0.712. E naught cell हो जाएगा. Now you have to identify the cathode and the anode. So the right hand side electrode is cathode and the left hand side electrode is anode. So E naught cell is E naught cathode minus E naught anode. So standard reduction potential of iron minus standard reduction potential of hydrogen. So 0.771 minus 0 is equal to 0.771 volt. Now the cell reaction will be, As you can see, here hydrogen is changing into H plus ion. So hydrogen undergoes oxidation and Fe3 plus is changing to Fe2 plus ion. So at the cathode, Fe3 plus ion is undergoing reduction. If you see the individual reaction, Fe3 plus will accept one electron and form Fe2 plus, and hydrogen gas will lose two electrons and form two H plus ions. Now to make the number of electrons equal, means number of electrons lost equal to number of electrons gained, just multiply this equation, that is reaction at the cathode, by 2. So the final redox equation is hydrogen plus 2 Fe3 plus forming 2H plus 2 Fe2 plus. Now the next equation is E cell, that is EMF of the cell, is equal to E naught cell minus 0.059 by N. Here number of electrons involved is 2. Log Fe2 plus means concentration of the ions in the product, that is Fe2 plus raised to the power 2, H plus raised to the power 2 divided by Fe3 plus raised to the power 2 and partial pressure of hydrogen. Here it will be partial pressure of hydrogen. Now putting the values, E naught cell is 0.771, E cell is 0.712. So rearranging the equation, 0.059 by 2 log product by reactants is equal to 0.771 minus 0.712, which is equal to 0.059. Solving, now H plus raised to the power 2, this is equal to 1. H plus ion concentration is 1, so 1 square is 1. Partial pressure of hydrogen is also 1. Log Fe2 plus raised to the power 2 divided by Fe3 plus raised to the power 2 will be 2 log Fe2 plus by Fe3 plus. Now here 0.059 and 0.059 cancel. 2 goes to the right hand side. Final equation is log A to the power 2 can be written as 2 log A. So 2 log Fe2 plus divided by Fe3 plus is equal to 2. 2 will cancel. Solving, log Fe2 plus by Fe3 plus is 1 and antilog, taking antilog 1 is 10. Antilog 1 is 10, so Fe2 plus by Fe3 plus is 10. So answer is 10. Question: in this electrochemical cell, the anode is made up of hydrogen electrode and cathode consists of metal M, and the reaction at the cathode is M3 plus ion changing into M plus, means M3 plus ion accepting 2 electrons and changing into M plus ions, aqueous solution of M plus ions. So aqueous solution of M3 plus ion plus 2 electron forming aqueous solution of M plus ions. This is the reaction at the cathode, and reaction at the anode is hydrogen losing 2 electrons and forming H plus ions. This is the reaction at the anode. And adding the reaction at the cathode and anode, the redox reaction is obtained, which is hydrogen plus M3 plus ion forming H plus ion and M plus ion. Now E cell will be equal to E naught cell minus 0.059 by N, where N is the number of electrons, log M plus ion multiplied by concentration of H plus ion raised to the power 2 divided by M3 plus ions, concentration of M3 plus ions, and partial pressure of hydrogen. Now in the question, E cell is given and ratio of the concentration of M plus ion to M3 plus ion is given as 10 to the power A, and you have to find out the value of A. Standard reduction potential of the metal is given as 0.2 volts. So E cell is 0.1115 and E naught cell is 0.2 minus 0.059 by number of electrons involved is 2 log M plus ion, concentration of M plus ion divided by concentration of M3 plus ion. Now here the concentration of H plus ion is given as 1M. So square of the H plus ion concentration will be equal to 1. Partial pressure of hydrogen is given as 1 bar. So this will also be 1. So in the final equation, it will be E cell equal to E naught cell minus 0.059 by 2 log concentration of M plus divided by concentration of M3 plus ion. Now rearranging this equation, 0.059 by 2 log M plus by M3 plus is equal to 0.2 minus 0.1115, that is E naught cell minus E cell, which is equal to 0.0885. So log M plus by M3 plus will be 0.0885. This 2 goes to the right hand side, so 0.0885 multiplied by 2 and divided by 0.059, which is equal to 3. So log of concentration of M plus to M3 plus ion is 3. Therefore antilog 3 will be 1000. Antilog 3 is 1000. This is 1000. So antilog 3 will give the ratio of the concentration of M plus to M3 plus ion, which is equal to 1000, or this can also be written as 10 to the power 3. So value of A, 10 to the power A is equal to 10 to the power 3. So value of A is equal to 3. Consider the cell. Now this is a cell here. Anode is standard hydrogen electrode. Pressure of hydrogen is 1 atmosphere and H plus ion concentration is 1 m, and cathode is made up of iron, where Fe3 plus is getting reduced to Fe2 plus. Now potential of the cell is given as 0.712 volt, means E cell value is given as 0.712 volt, and you have to find the ratio of Fe2 plus to Fe3 plus ion, means concentration of Fe2 plus ion divided by concentration of Fe3 plus ion. Reduction potential of iron electrode is given as 0.771. Formula for E naught cell is equal to E naught cathode minus E naught anode, that is standard cell potential is equal to standard reduction potential of cathode minus standard reduction potential of anode. Cathode standard reduction potential is given in the question as 0.771 minus standard reduction potential of anode, that is hydrogen electrode, is 0. Standard reduction potential of hydrogen is 0. So 0.771 minus 0 is equal to 0.771. So this is the E naught cell, and EMF of the cell is given as 0.712. So applying Nernst equation, EMF of the cell is equal to E naught cell minus, here the value of 2.303 RT by F is given as 0.06. So 0.06 divided by number of electrons involved in this reaction. Now here the number of electrons involved will be, if you see the reaction at the cathode, the reaction at the cathode is Fe3 plus ion accepting 1 electron to form Fe2 plus ion, and reaction at the anode is hydrogen gas changing into H plus ion, so it gives 1 electron. Here to balance the equation, this will be half H2. So number of electrons accepted is equal to number of electrons given, and which is equal to 1 electron here. So value of N is 1 log, in the redox reaction the product side has Fe2 plus and H plus ions. So Fe2 plus ion, concentration of Fe2 plus ion multiplied by concentration of H plus ion, divided by, on the reactant side, Fe3 plus ion and hydrogen gas, so concentration of Fe3 plus ion and partial pressure of hydrogen raised to the power half. Concentration of H plus ions is 1, partial pressure of hydrogen is 1. So final equation becomes E naught cell is 0.771, E cell is 0.712. This is partial pressure of hydrogen raised to the power half. This is 1 m. This is 1 atmosphere. Putting the values and rearranging, 0.06 log concentration of Fe2 plus divided by concentration of Fe3 plus is equal to 0.771 minus 0.712, which is equal to 0.059. So log of concentration of Fe2 plus by Fe3 plus is equal to 0.059 by 0.06, which is equal to 1. So anti-log of 1 is 10. So concentration of Fe2 plus by Fe3 plus is 10. So answer is 10. The electrode potential of the following cell at 298 Kelvin. At the anode, X is changing into X plus 2 and concentration of the X plus 2 ions is 0.001 moles per liter. And now this is the anode and this is the cathode. At the cathode, reduction is taking place. Y2 plus ion is changing into Y. Concentration of Y2 plus ion is 0.01 moles per liter. E cell you have to find out. Standard reduction potential values of X and Y are given. E naught cell will be equal to E cathode minus E anode. So E naught cathode is 0.36 minus in brackets E naught anode, which is minus 2.36. Solving, E naught cell is 2.72. The reaction at the anode is X changing into X plus 2 ion giving 2 electrons and the concentration of ion is 0.001 moles per liter. And at cathode, Y plus 2 is accepting 2 electrons and changing into Y, and concentration of the ion, that is Y plus 2 ion, is 0.01 mole per liter. Number of electrons lost is equal to number of electrons gained. Adding these two equations, this is the anode, it is the oxidation reaction, and at cathode it is the reduction reaction. Adding these two equations, electrons on both the sides get cancelled and you get this redox reaction. So E cell will be equal to E naught cell minus, now 2.303 RT by F is given as 0.06. So 0.06 divided by number of electrons. Now number of electrons participating in this redox reaction is 2. Log product divided by reactant. In the product, X plus 2 ion multiplied by Y divided by concentration of Y plus 2 ions multiplied by X. Now concentration of Y, since it is in its atomic state, will be taken as 1, X will be taken as 1. Putting the values of the concentration of the ions and E naught cell, the equation becomes E cell is equal to 2.72 minus 0.06 divided by 2 log 0.001 divided by 0.01. Now 0.001 divided by 0.01. This will be, removing the decimal, this will be into 100, this is into 1000 and 100 cancels and you get this as 1 by 10. So this will be log 10 to the power minus 1, which is equal to minus 1. So this whole value is equal to minus 1 and 0.06 divided by 2 will be equal to 0.03. Now 0.03 multiplied by log 0.001 divided by 0.01, that is minus 1. So 0.03 multiplied by minus 1 will be minus 0.03. Then again 2. So this becomes 2.72 minus 0.03, which will be equal to 2.72 plus 0.03, and this is equal to 2.75 volt, and this can also be written as 275 into 10 to the power minus 2 volt. So E cell will be equal to, here in the fill in the blanks it will be 275 into 10 to the power minus 2 volt. The resistivity of a 0.8 m solution of an electrolyte is 5 into 10 to the power minus 3 ohm centimeter. Its molar conductivity is dash into 10 to the power 4 per ohm centimeter square per mole. मोलर कंडक्टिविटी का फॉर्मूला होता है कंडक्टिविटी मल्टीप्लाइड बाई 1000 डिवाइडेड बाई मोलैरिटी. Now what is conductivity? Conductivity is inverse of resistivity. कंडक्टिविटी इज इनवर्स ऑफ रेजिस्टिविटी. तो कंडक्टिविटी की यूनिट क्या हो जाएगी? कंडक्टिविटी की यूनिट हो जाएगी, रेजिस्टिविटी की यूनिट अगर ओम सेंटीमीटर है एज गिवन इन द क्वेश्चन, कंडक्टिविटी की हो जाएगी पर ओम पर सेंटीमीटर, और यहाँ पे कंडक्टिविटी की वैल्यू हो जाएगी 1/5 इंटू 10⁻³ मोलर कंडक्टिविटी. हाउ इज दिस फॉर्मूला डिराइव्ड? मोलर कंडक्टिविटी इज एक्चुअली conductivity multiplied by volume of solution in centimeter cube containing 1 mole of the electrolyte. So if molarity of any solution is given as, suppose here molarity is given as 0.8 m, means 0.8 moles per liter, means in 1 liter there are 0.8 moles. Or it can be said 0.8 moles are present in 1 liter or 1000 centimeter cube. Therefore 1 mole is present in 1000 divided by 0.8 centimeter cube. So molar conductivity will be equal to conductivity multiplied by volume of solution in centimeter cube containing 1 mole of electrolyte. And what is that volume here? It is 1000 by 0.8 centimeter cube. So this is how the formula is derived. Now if you see what is this 0.8, this is nothing but the molarity. So this formula can be written as conductivity multiplied by 1000 divided by molarity. Conductivity, this is the value of conductivity multiplied by 1000 divided by 0.8. So solving 1/5 into 10⁻³ into 1000 divided by 0.8. Removing the decimal, this will be into 10. Then 8 1s are 8, 8 2s are 16, 8 5s are 40. Then 5, 5 2s are 10, 5 5s are 25. Solving, this is equal to 25 into 10⁴. Now for the units, how to find the unit? Molar conductivity is equal to conductivity. What is the unit of conductivity? Per ohm per centimeter multiplied by 1000 divided by molarity. Molarity here is in moles per centimeter cube. Since the unit of length is in centimeter, molarity is also in moles per centimeter cube. That is, here it will be moles and in the numerator this will be centimeter cube. So centimeter inverse and centimeter cube, if you cancel it, it will become centimeter square. This becomes equal to per ohm centimeter square per mole. So this is the unit of molar conductivity. So this is per ohm centimeter square per mole. This is per ohm, and here the answer will be 25. 2 moles of ozone change into 3 moles of oxygen gas. Temperature is 300 Kelvin and ozone is 50% dissociated. The standard free energy change at this temperature and 1 atmosphere pressure is minus dash joule per mole, and given natural log of 1.35 is 0.3, value of R is given. Answer has to be given in nearest integer. 2 moles of ozone change into 3 moles of oxygen. So 2 moles of ozone, 3 moles of oxygen. 1 mole of ozone will give 3/2 moles of oxygen. So if alpha moles of ozone is there, then 3/2 alpha moles of oxygen will be formed. Now alpha is the degree of dissociation. How to find the degree of dissociation? It is given in the question that ozone is 50% dissociated. 50% means out of 100, 50 moles is dissociated. If initially 100 moles is present, then 50 moles is dissociated. Therefore, out of 1, how many moles will be dissociated? Out of 100, if it is 50, then out of 1 it will be 50 by 100, which is equal to 0.5 moles. And this is the degree of dissociation denoted by alpha. So out of 1 mole, alpha moles is dissociated, and when alpha moles of ozone dissociates, it gives 3/2 alpha moles of oxygen. So remaining ozone at equilibrium is 1 minus alpha and oxygen formed at equilibrium is 3 by 2 alpha. Putting the value of alpha and solving, moles of ozone is 0.5 and moles of oxygen is 0.75. So total moles will be 0.5 plus 0.75, which is 1.25 moles. Now partial pressure of oxygen is equal to moles of oxygen divided by total moles multiplied by total pressure. So this is equal to 0.6 atmosphere. Partial pressure of ozone is equal to moles of ozone divided by total number of moles multiplied by total pressure, and partial pressure of ozone is 0.4 atmosphere. Value of Kp will be partial pressure of oxygen raised to the power 3, because 3 is the stoichiometric coefficient of oxygen in the balanced equation, divided by partial pressure of ozone raised to the power 2, as 2 is the stoichiometric coefficient of ozone in the balanced equation. Putting the values of partial pressure of oxygen and partial pressure of ozone and solving, value of Kp is 1.35 atmosphere. Now delta G is equal to minus RT natural log of K. Putting the value of R and T, natural log of 1.35. This is natural log of Kp. So natural log of Kp means natural log of 1.35, which is given in the question as 0.3. So value of delta G is minus 8.3 into 300 into 0.3, which is equal to minus 747 joule per mole. So here the answer will be 747. Minus sign is already given in the question, so 747 joule per mole. The cell potential for the following cell: anode is a standard hydrogen electrode, cathode is of copper dipping in Cu2 plus ion solution. Now cell potential is given as 0.575 volt and you have to find the pH of the solution. Standard electrode potential of copper is given as 0.34 and standard electrode potential for hydrogen is equal to 0. Hydrogen here is acting as the anode, copper is acting as the cathode. Value of 2.303 RT by F is given as 0.06. So applying Nernst equation, E cell is E naught cell minus 2.303 RT by NF log H plus ion concentration raised to the power 2 divided by copper ion concentration. Now the redox reaction will be hydrogen plus Cu2 plus forming 2H plus ions plus copper, and the number of electrons involved will be 2. Here Cu2 plus is changing into Cu, means it is accepting 2 electrons. Hydrogen is changing into 2H plus, means it is losing 2 electrons. So number of electrons is 2, value of N is 2. E naught cell is E cathode minus E anode. So E naught cell is equal to, cathode is copper, so 0.34 minus anode is a standard hydrogen electrode, so it is 0. So this is equal to 0.34 volts. So E naught cell is 0.34 volts. E cell is given as 0.576 and value of 2.303 RT by F is 0.06. So putting the values in the balanced equation, H plus ion stoichiometric coefficient is 2. So log H plus raised to the power 2 divided by copper ion concentration, which is given in the question as 0.01. Now here the concentration of neutral copper atom is 1, partial pressure of hydrogen is 1. So in the Nernst equation, even if you write the concentration of copper and partial pressure of hydrogen, since it is equal to 1, the final expression will be log H plus whole square divided by 0.01. Now solving this equation, the final equation is 7.86 is equal to minus log H plus whole square divided by 10 to the power minus 2. Now taking minus outside the bracket, inside the bracket it is log H plus whole square minus log 10 to the power minus 2. Now minus log 10 to the power minus 2 can be written as minus, and log 10 to the power minus 2 is again minus 2. So opening the bracket, it becomes plus 2. And log H plus ion raised to the power 2 will be 2 log H plus, and minus log 10 to the power minus 2 is equal to plus 2. Opening the brackets, this becomes minus 2 log H plus minus 2. Then taking minus 2 to the left hand side, it will be 7.86 plus 2, which is 9.86, which is equal to minus 2 log H plus. Taking 2 to the left hand side, this becomes minus log H plus, which is actually the pH of the solution, is equal to 9.86 divided by 2, which is equal to 4.93, or approximately it is equal to 5. So pH of the solution to the nearest integer will be 5. 20 milliliter of 0.02 m hypo solution is used for the titration of 10 milliliter of copper sulfate solution in the presence of excess of Ki using starch as an indicator. The molarity of Cu2 plus is found to be dash into 10 to the power minus 2m, and the ionic reaction is given, the balanced ionic reaction is given. Cu2 plus ions are coming from copper sulfate, I minus from Ki, S2O3 2 minus from hypo. Formula for hypo is Na2S2O3, and this ionizes as 2Na plus S2O3 2 minus. Now, as can be seen from the balanced ionic reaction, 2 moles of Cu2 plus ions react with 4 moles of iodide ion and give 1 mole of Cu2I2 and 1 mole of iodine. So 2 moles of Cu2 plus ion give 1 mole of iodine. This 1 mole of iodine then reacts with 2 moles of hypo. So this 1 mole of iodine reacts with 2 moles of hypo solution. Therefore, it can be written 2 moles of Cu2 plus ions give 1 mole of iodine, and this 1 mole of iodine reacts with 2 moles of a hypo solution. So it can be seen that moles of hypo is same as moles of Cu2 plus ions. This N denotes the number of moles. So it can be written that moles of copper sulfate is equal to, now this Cu2 plus ion is coming from copper sulfate. So moles of copper sulfate is equal to moles of hypo. What is the moles of copper sulfate? Moles of copper sulfate will be equal to molarity of copper sulfate, let it be m, multiplied by volume of copper sulfate in liters. It will be 10 divided by 1000 liter. And since moles of copper sulfate is same as moles of hypo, it can be written as molarity into volume of copper sulfate, that is moles of copper sulfate, is equal to moles of hypo. And what will be the moles of hypo? Moles of hypo will be molarity of hypo, that is 0.02, multiplied by volume of hypo in liters. It will be 20 divided by 1000. Now 1000 cancel, 10 2s are 20. So molarity of the copper sulfate solution is 0.04 moles per liter, or it can also be written as 4 into 10 to the power minus 2 moles per liter, which is denoted by m. So here the answer will be 4, and molarity of copper sulfate will be 4 into 10 to the power minus 2. 0.01 molar KMnO4 solution was added to 20 milliliter of 0.05 m more salt solution through a burette. The initial reading of 50 ml burette is 0. The volume of KMnO4 solution left in the burette after the end point is dash milliliter. What is more salt? More salt is ferrous ammonium sulfate. And in this reaction, Fe2 plus ion present in the more salt reacts with MnO4 minus to form Fe3 plus ion and Mn2 plus. The oxidation state of manganese in MnO4 minus is plus 7 and oxidation state of manganese in the product is plus 2. So decrease in the positive oxidation state from plus 7 to plus 2. So the change in the oxidation number of each atom of manganese is by 5, or in other words manganese accepts 5 electrons. On the other hand, Fe2 plus is oxidized to Fe3 plus. Therefore, change in oxidation number of iron is by 1. So, moles of electron which iron loses is 1. So, valency factor of iron is 1 and valency factor of manganese is 5. Now, applying the formula, molarity of Mohr salt, that is 0.05, multiplied by volume of Mohr salt in liters, that is 20 by 1000, multiplied by valency factor of Mohr salt, that is 1, is equal to molarity of KMnO4 solution, that is 0.01, multiplied by volume of KMnO4 solution, which is not given in the question, let it be V, multiplied by valency factor of KMnO4, which is 5. Now solving this equation, 0.01 and 0.05 cancel, 0.01 5s are 0.05 and then 5 gets cancelled. So volume is equal to 20 by 1000 liter, or in milliliter the volume will be 20 milliliter. So volume of KMnO4 used in the titration is 20 milliliter. Volume of KMnO4 present, that is initial volume, is 50 milliliter. So volume of KMnO4 left in the burette is initial volume minus volume used in titration, which is equal to 30 milliliter. So volume of KMnO4 left in the burette after the end point is 30 milliliter. The resistance of a conductivity cell containing 0.01 m KCl solution at 298 Kelvin is 1750 ohm. If the conductivity of 0.01 m KCl solution at 298 Kelvin is 0.152 into 10 to the power minus 3 per ohm per centimeter, then the cell constant of the conductivity cell is dash into 10 to the power minus 3 per centimeter. Resistance is given, molarity of the KCl solution is given as 0.01 m. Now for the same KCl solution having molarity 0.01 m, the conductivity is 0.152 into 10 to the power minus 3 per ohm per centimeter. Now R is equal to, resistance is equal to resistivity into cell constant. If you take the inverse on both the sides, then 1 by R is equal to 1 by rho multiplied by 1 by cell constant. 1 by rho, this is equal to conductivity. Inverse of resistivity is conductivity. So it can be written that cell constant is equal to R into conductivity. So cell constant is equal to R into conductivity. Putting the values, the value of cell constant is 0.266 per centimeter or 266 into 10 to the power minus 3 per centimeter. So answer here will be 266. So cell constant is 266 into 10 to the power minus 3 per centimeter. In a cell, the following reactions take place: Fe2 plus changing to Fe3 plus, 2I minus changing to iodine. Both these are oxidation reactions. Reduction potential of iron and reduction potential of iodine is given. The standard electrode potential for the spontaneous reaction in the cell is X into 10 to the power minus 2 volt at 298 Kelvin. The value of X is dash. Out of iron and iodine, which one has higher reduction potential value? Iron has higher reduction potential value than iodine. So iron will act as the cathode and iodine will act as the anode. This electrode will act as the anode. So applying the formula, E naught cell is E naught cathode minus E naught anode. What is E naught cathode? 0.77 volt minus E naught anode is 0.54 volt. So E naught cell is 0.23 volt or 23 into 10 to the power minus 2 volt. So here the value of X will be 23. A solution of Fe2SO4 whole thrice is electrolyzed for X minute with a current of 1.5 ampere to deposit 0.3482 gram of iron. The value of X is 1 Faraday is equal to 96500 coulomb per mole. Atomic mass of iron is 56 gram per mole. Fe2SO4 whole thrice, the oxidation state of iron is +3. Now from this oxidation state, if iron has to go to zero oxidation state, means to deposit iron, 3 moles of electron will be required. 1 mole of Fe3 plus iron will require 3 moles of electron. So charge carried by 1 mole of electron is 96500 coulomb. Therefore 3 moles of electron will have charge 3 into 96500 coulomb. In other words, it can be said that to deposit 1 mole of iron, 3 moles of electron is required, or to deposit 1 mole of iron, 3 into 96500 coulomb of charge is required. And 1 mole of iron means 56 gram of iron. So 56 gram of iron requires 3 into 96500 coulomb of charge. Therefore 0.3482 gram of iron will require 3 into 96500 into 0.3482 divided by 56, which is equal to 1800 coulombs. Now charge is equal to current into time in seconds. Putting the value of charge 1800 coulomb, current is 1.5 ampere into time. Time you need to find out. So value of time will be equal to 1800 divided by 1.5. Time will be equal to Q divided by I. So time is 1200 seconds, and if it is converted into minutes divided by 60, in minutes the time is 20 minutes. So value of X is 20. The limiting molar conductivities of sodium iodide, sodium nitrate and silver nitrate are 12.7, 12 and 13.3 per ohm meter square per mole respectively, all at 25 degrees centigrade. The limiting molar conductivity of silver iodide at this temperature is dash per ohm meter square per mole. Now limiting molar conductivity of sodium iodide is sum of the limiting molar conductivity of sodium and iodide ion. Limiting molar conductivity of sodium nitrate will be the sum of limiting molar conductivity of sodium and nitrate ion. And the limiting molar conductivity of AgNO3 is sum of limiting molar conductivities of silver ion and nitrate ion. Values of limiting molar conductivity of sodium iodide is given, that is 12.7. For sodium nitrate it is 12 and for AgNO3 it is 13.3. You have to find out limiting molar conductivity of silver iodide. So limiting molar conductivity of silver iodide is equal to limiting molar conductivity of silver ion plus limiting molar conductivity of iodide ion. Let this be equation 1, this equation 2 and this equation 3. If you add 1 and 3, you get the sum of the limiting molar conductivity of sodium ion, iodide ion, silver ion and nitrate ion. On adding 1 and 3, limiting molar conductivity of all these 4 ions will get added. But you need the limiting molar conductivity of silver iodide. You do not need the limiting molar conductivities of sodium and nitrate. For that, subtract the limiting molar conductivity of sodium nitrate, which is sum of the limiting molar conductivities of sodium and nitrate ions. So on subtracting the limiting molar conductivity of sodium nitrate from the sum of limiting molar conductivity of sodium iodide and silver nitrate, the limiting molar conductivities of sodium ions will get cancelled and nitrate ion will get cancelled, and what will be left? Limiting molar conductivity of silver and iodide ion will be left. So 1 plus 3 minus 2. This is equal to limiting molar conductivity of silver ion plus limiting molar conductivity of iodide ion, which is equal to limiting molar conductivity of silver iodide, which is asked in the question. So put the values. Limiting molar conductivity of sodium iodide is given as 12.7. So 12.7 plus limiting molar conductivity of silver nitrate is given as 13.3 minus limiting molar conductivity of sodium nitrate, that is 12. So this is 26 minus 12, which is equal to 14. So the answer here is 14 per ohm meter square per mole. Limiting molar conductivity of silver iodide is 14. Acidified potassium permanganate solution oxidizes oxalic acid. The spin-only magnetic moment of the manganese product formed from the above reaction is dash Bohr magneton. Now the reaction is potassium permanganate gives permanganate ion, oxalic acid, oxalate ion. So permanganate ion reacts with oxalate ion and forms Mn2 plus ion plus CO2 plus H2O. This reaction takes place in acidic medium. Now the product formed is Mn2 plus ion. You have to find out the spin only magnetic moment of the manganese product formed. Means spin only magnetic moment of Mn2 plus ion you have to find. Now what is the atomic number of manganese? It is 25, and electronic configuration of manganese is argon 3d5 4s2, and when Mn2 plus ion is formed, 2 electrons are lost. So this becomes 3d5 4s. This will not be 2. 4s electrons will be lost, and the electronic configuration of Mn2 plus ions will be argon 3d5. The 2 electrons in the 4s orbital will be lost, giving 2 units of positive charge on Mn2 plus ion, and the total number of electrons in Mn2 plus ion is 23. So this is the electronic configuration. Now from the electronic configuration, it can be seen that the 3d orbital has 5 electrons. There are 5 electrons in the 3d orbital, means d orbital is half filled. So there are 5 unpaired electrons in the d orbital. So number of unpaired electrons is 5, and the spin only magnetic moment is equal to n plus 2 square root of n plus 2, where n is number of unpaired electrons. So this becomes 5 into 5 plus 2. This is equal to square root of 35, which is equal to 5.91 Bohr magneton, and the nearest integer value will be 6 Bohr magneton. So the correct answer is 6. For the reaction taking place in the cell, platinum, this is hydrogen gas changing into H plus ion, Ag plus aqueous changing into Ag solid. E naught cell is given as plus 0.5332 volt. The value of delta G naught is dash kilojoule per mole. Anode is hydrogen electrode, cathode is silver electrode. Now here hydrogen gas is getting oxidized to H plus ion, silver is getting reduced to solid silver. Cathode reduction is taking place, anode oxidation is taking place. Now hydrogen is changing into H plus ion at anode, so hydrogen is the reactant at the anode. Ag plus is changing into solid silver, so silver ion is the reactant at the cathode. So hydrogen plus silver ion forming. Product at the anode is H plus ion, product at the cathode is solid silver. H plus ion and solid silver. Now to balance the equation, this will be half H2 Considering the individual reactions, the reaction at the anode is oxidation reaction where hydrogen changes into H plus ion giving one electron, and this one electron is accepted by Ag plus ion and it is changing into solid silver. So number of electrons involved in this reaction is 1. Applying the formula delta G naught is equal to minus NF E naught. So minus N, value of N is 1, F is 96500 coulomb per mole, and E naught value is 0.5332 volt. Solving value of delta G in joule per mole will be minus 51,453.8 joule, and to change it into kilojoule just divide it by 1000, so it becomes minus 51.45 kilojoule per mole. Now to give the value in nearest integer, the value of delta G naught will be minus 51 kilojoule per mole. The quantity of electricity in Faraday needed to reduce 1 mole of Cr2O7 to minus 2 Cr3 plus is. Now to find the quantity of electricity, first of all you need to know how many electrons are accepted when Cr2O7 to minus changes to Cr3 plus. तो सबसे पहले ऑक्सीडेशन स्टेट ऑफ क्रोमियम इन Cr2O7 माइनस फाइंड आउट कर लेते हैं. लेट द ऑक्सीडेशन स्टेट ऑफ क्रोमियम इन Cr2O7 माइनस बी Z. तो Z हो गया ऑक्सीडेशन स्टेट ऑफ क्रोमियम इन Cr2O7 माइनस. नाउ दिस इज द ऑक्सीडेशन स्टेट ऑफ ईच क्रोमियम एटम. हाउ मेनी क्रोमियम एटम्स आर देयर इन Cr2O7 माइनस 2. तो यहाँ पे हो जाएगा 2 into oxidation state of each chromium atom plus 7, number of oxygen atoms is 7, multiplied by oxidation state of each oxygen atom, that is minus 2. और overall charge इस anion में कितना है? Overall charge है 2 minus, so this is equal to minus 2. Therefore 2Z minus 14 is equal to minus 2. 2Z will be equal to minus 2 plus 14, which is equal to 12, and Z is equal to 12 divided by 2, that is 6. So each chromium atom in Cr2O7 minus has oxidation state of plus 6, and now it is changing to Cr3 plus, that is from plus 6 oxidation state it is changing into plus 3 oxidation state. So oxidation state of each chromium atom is changing from plus 6 to plus 3, means Cr2O7 minus, when it is changing from Cr2O7 minus to chromium in plus 3 oxidation state, then oxidation state of each chromium atom is changing from plus 6 to plus 3. Now to balance the number of chromium atoms, here it will be 2 Cr3 plus. So for one chromium atom, the change in oxidation state is from plus 6 to plus 3, that is by 3. Therefore for 2 chromium atoms, the change in oxidation number will be by 3 into 2, that is 6. So total change in oxidation number is by 6. So here Cr2O7 minus will accept 6 electrons and it will change into 2 Cr plus 3. So total number of electrons accepted by Cr2O7 minus is 6 electrons. Or it can also be said 1 mole of Cr2O7 minus accepts 6 moles of electrons. 1 mole of electron is 1 Faraday, 6 mole of electrons will be 6 Faraday. So quantity of electricity in Faraday needed to reduce 1 mole of Cr2O7 minus to Cr3 plus is 6. For the given reactions, Sn2 plus accepting 2 electrons changing into tin and Sn4 plus 4 electron changing into tin. The reduction potential value of tin 2 plus ion changing into tin is minus 0.140 volt, and tin 4 plus ion changing into tin, the reduction potential value is 0.010 volt. The magnitude of standard electrode potential for tin 4 plus ion changing into tin 2 plus ion is dash into 10 to the power minus 2. Now tin 4 plus ion accepting 2 electrons changing into tin 2 plus ion, then tin 2 plus ion changing into tin accepting 2 electrons. Let the delta G values be delta G3 and delta G1 respectively, and tin 4 plus ion changing into tin, the delta G value, let it be delta G2. Electrode potential value, you cannot obtain the electrode potential value by adding the electrode potential of various steps, but delta G values are additive, so delta G value for different steps can be added. So it can be written that delta G2 is equal to delta G3 plus delta G1. See here, delta G2, it is the step where tin 4 plus ion is changing into tin, and delta G2 is equal to delta G3 plus delta G1. These are the delta G values for the steps like SN4 plus changing to SN2 plus and SN2 plus changing to SN. Now delta G2 can be written as N2 F E2 naught, which is equal to delta G3 will be equal to N3 F E3 naught plus, this will be with negative sign, minus delta G value is equal to minus NFE. So delta G naught is equal to minus NFE naught, and this becomes N1F E1 naught. This is minus and this will be in brackets minus. Now putting the values, N2, what is N2? N2 is the number of electrons involved in the step when SN4 plus changes to SN, that is for delta G2 number of electrons involved is 4. 4 electrons are involved, so this is the value of N2. Value of N3 will be the step involving the change of tin 4 plus ion into tin 2 plus ion. Delta G value is delta G3 and number of electrons involved is 2 electrons, so this is N3, and similarly this is equal to N1, number of electrons involved in the step whose delta G value is delta G1. So putting the values, N2 is 4, so this is minus 4 into F into E naught 2 is 0.010, and this is equal to minus value of N3 is 2 into F into E naught 3. E naught 3 value is, E naught 3 value you have to find out, and opening the bracket here, this becomes minus, what is N1? N1 is again 2 into F into E naught 1 is, E naught 1 is minus 0.140. Taking 2F common on this side, on the right hand side, taking minus 2F common, in the bracket what is left? E naught 3 minus 0.140. Now F cancels, here minus will cancel, and this will be 2 1s are 2, 2 2s are 4. Solving, the value is 0.010 is equal to E naught 3, here it will be 2 into 0.010 is equal to E naught 3 minus 0.140. This becomes 0.020 is equal to E naught 3 minus 0.140. Now solving this, E naught 3 is equal to 0.020 plus 0.140. This becomes 0.160, or it can also be written as, this is also equal to 16 into 10 to the power minus 2. So here the correct answer will be, now here in the fill in the blanks it is given as value of E naught tin 4 plus changing to tin 2 plus, that is reduction potential for this change, is equal to dash into 10 to the power minus 2. So here in the fill in the blanks the answer will be 16, because the correct answer is E03 is equal to 16 into 10 to the power minus 2. This is the E03 value when tin 4 plus ion changes to tin 2 plus ion. E03 is the value of reduction potential when tin 4 plus ion changes to tin 2 plus ion. And these are delta G02, delta G03, delta G01. Here this is delta G03, delta G01, delta G02. The solubility product of a sparingly soluble salt A2X3 is 1.1 into 10 to the power minus 23. If specific conductance of the solution is 3 into 10 to the power minus 5 per ohm per meter, the limiting molar conductivity of the solution is x into 10 to the power minus 3 per ohm meter square per mole. The value of x is, now A2X3 will dissociate to give 2 moles of A3 plus ion and 3 moles of X2 minus ion. How to decide the charge on A and X? The formula A2X3 is obtained by crossing the valencies of A and X. Suppose valency of A is M and valency of X is N. Then valency of A is M, valency of X is N. Then crossing the valency, formula becomes A, N, X, M. Compare the formula with A2X3. N is equal to 2, M is equal to 3. So valency of A is 3 and valency of X is 2. So A forms the positive ion having 3 units of positive charge and X forms the negative ion having 2 units of negative charge. Plus 3 minus 2 are the oxidation states of A and X in A2X3. Now alpha moles of A2X3 will dissociate to give 2 alpha moles of A3 plus ion and 3 alpha moles of X2 minus ion. So solubility product will be equal to concentration of A3 plus ion raised to the power 2 multiplied by concentration of X2 minus ion raised to the power 3. 2 and 3 are the stoichiometric coefficients of A3 plus and X2 minus ion in the balanced equation. Concentration of A3 plus ion is 2 alpha. So 2 alpha raised to the power 2. Concentration of X2 minus ion is 3 alpha. So 3 alpha raised to the power 3. Solving KSP value is 108 alpha raised to the power 5. And this is equal to 1.1 into 10 to the power minus 23 as given in the question. So alpha raised to the power 5 will be equal to 1.1 divided by 108 into 10 to the power minus 23. Solving alpha raised to the power 5 will be 10 to the power minus 25. 1.1 divided by 108 is 0.01. So 0.01 into 10 to the power minus 23 is 10 to the power minus 25. So alpha will be equal to 10 to the power minus 25 raised to the power 1 by 5, or it can also be said fifth root of 10 to the power minus 25. So this is equal to 10 to the power minus 5. So value of alpha is 10 to the power minus 5 moles per liter. Now lambda m, that is molar conductivity, is equal to conductivity divided by alpha or specific conductance divided by alpha. Now value of specific conductance is in per ohm per meter, whereas alpha is in moles per liter. So this moles per liter has to be converted into moles per meter cube. The unit of length has to be in meters because in the value of specific conductance the unit of length is in meters. Now how to convert moles per liter to moles per meter cube? 10 to the power minus 5 mole per liter can be written as 10 to the power minus 5 mole and in the denominator it is liter. Now 1 liter is equal to 10 to the power minus 3 meter cube. So to convert liter into meter cube, just multiply this by 10 to the power minus 3 and the conversion factor is 10 to the power minus 3 meter cube per liter, means 1 liter is equal to 10 to the power minus 3 meter cube. Liter gets cancelled and 10 to the power minus 3 goes in the numerator. So this becomes 10 to the power minus 5 multiplied by 10 to the power 3 mole per meter cube, mole per meter cube, which is equal to 10 to the power minus 2 mole per meter cube. So here 10 to the power minus 5 mole per liter is equal to 10 to the power minus 2 mole per meter cube. Molar conductivity is equal to specific conductance divided by value of alpha. So 3 into 10 to the power minus 5 divided by 10 to the power minus 2. This is equal to 3 into 10 to the power minus 3 per ohm meter square per mole. But the value given in the question is x into 10 to the power minus 3. So x into 10 to the power minus 3 is equal to 3 into 10 to the power minus 3. So 10 to the power minus 3, 10 to the power minus 3 cancel and value of x is equal to 3. So the value of x is 3. The cell potential for zinc changing to zinc ion and tin ion changing to tin is 0.801 volt at 298 Kelvin. The reaction quotient for the above reaction is 10 to the power minus 2. The number of electrons involved in the given electrochemical cell reaction is. Now reduction potential of zinc is given as, this will be minus 0.763 volt and here for tin it is 0.008 volt. Value of 2.303 RT by F is given as 0.06. This is the cell representation. This is the anode and this is the cathode. Zinc changing to Zn2 plus ion by losing 2 electrons. Tin ion changing to tin by gaining X electrons. Now you have to find the value of N, that is the number of electrons which are involved in this redox reaction. This is the redox reaction. Now EMF of the cell is given as 0.801 volt. Now this is the redox reaction taking place in the cell and the reaction quotient for this redox reaction is product of the concentration of product, and what are the products? Zinc ion and tin are the product, divided by product of the concentration of reactant. Now what are the reactants? Zinc and tin ion are the reactants. Concentration of metallic tin is 1, concentration of metallic zinc is 1, and the reaction quotient is the ratio of zinc ions and tin ions which are present in the solution, which is equal to 10 to the power minus 2. This is given in the question. Standard EMF of the cell will be equal to reduction potential of the cathode minus reduction potential of the anode. Now cathode is tin, so reduction potential of cathode is 0.008 volt minus, this will be written as 0.008 volt minus reduction potential of anode. Reduction potential of anode means reduction potential of zinc, which is minus 0.763. Opening the brackets, minus minus will become plus. So the standard EMF of this cell will be 0.008 plus 0.763, which is equal to 0.771 volt. Now EMF of the cell is equal to standard EMF minus 2.303 RT by NF log K. Value of K is 10 to the power minus 2. 2.303 RT by F. This value is given in the question as 0.06. E naught value for the cell is 0.771. E is 0.801. So this can be written as 0.801 is equal to 0.771 minus 0.06 divided by n log 10 to the power minus 2. Now log 10 to the power minus 2, log 10 to the power minus 2 is equal to minus 2 log 10 to the base 10, which is equal to minus 2 into 1. As log 10 to the base 10 is 1, so this is equal to minus 2. Solving this equation, 0.771 coming to the left hand side it will become 0.801 minus 0.771, which is equal to 0.03. Then log 10 to the power minus 2 is equal to minus 2. So it will become plus 2, that is 2 into 0.06 divided by n. So 0.03 is equal to 2 into 0.06 divided by n. Solving, n is equal to 2 into 0.06 divided by 0.03. 0.03 2 is 0.06. So this cancels out and value of n is 2 into 2, 4. So in this redox reaction, the number of electrons involved is 4. Here the answer will be 4. This part of the equation, it can be written as 0.801 minus 0.771, and this is equal to minus 2 multiplied by minus 0.06 divided by n. Minus into minus is plus. So this becomes 2 into 0.06 by n, and here this value is equal to 0.03. So putting the values, the equation is 0.03 is equal to 2 into 0.06 by n. Solving, value of n is 4. 20 milliliter of 0.02 m K2Cr2O7 solution is used for the titration of 10 milliliter of Fe2 plus solution in the acidic medium. The molarity of Fe2 plus solution is dash into 10 to the power minus 2m. Now this reaction is carried out in acidic medium. In acidic medium, this K2Cr2O7, now each chromium atom has oxidation state of +6 and it is reduced to +3 oxidation state. Each chromium atom, the oxidation state is reduced from +6 to +3. So change in oxidation state for each chromium atom is 3, and in one molecule of K2Cr2O7 there are 2 chromium atoms. So change in oxidation state for 2 chromium atoms will be 3 into 2, which is equal to 6. So valency factor of chromium here will be, so the valency factor will be 6. Now Fe2 plus in the presence of K2Cr2O7 in acidic medium is getting oxidized to Fe3 plus. So change in oxidation state per atom of iron is 1. So here the valency factor of iron is 1. The formula that will be used to solve this question will be molarity into volume into valency factor of K2Cr2O7 is equal to molarity into volume into valency factor of iron. What is molarity into volume into valency factor? This is equal to number of equivalents. Molarity into volume gives number of moles and multiplied by, and number of moles multiplied by valency factor will give number of equivalents. Now number of equivalents of potassium dichromate will be equal to number of equivalents of Fe2 plus ion. Putting the values, number of equivalents of potassium dichromate will be equal to molarity of potassium dichromate given in the question as 0.02 multiplied by volume, that is 20 milliliter. Since the volume is in milliliters, molarity into volume will give millimoles multiplied by valency factor, which is 6, and this is equal to molarity of Fe2 plus ion solution you have to find multiplied by volume of Fe2 plus ion solution, that is 10, multiplied by valency factor of Fe2 plus ion, that is 1. So molarity of Fe2 plus ion will be 0.02 into 20 into 6 divided by 10. Solving, 10 2s are 20 and 6 into 2 into 0.02 will be equal to 0.24, which can also be written as 24 into 10 to the power minus 2 moles per liter, or 24 into 10 to the power minus 2 m. So molarity of Fe2 plus ion solution is 24 into 10 to the power minus 2 m. So in the fill in the blanks here, the answer will be 24. So the molarity of Fe2 plus ion solution is 24 into 10 to the power minus 2 m. In the titration of KMnO4 and oxalic acid in acidic medium, the change in oxidation number of carbon at the end point is dash. Oxalic acid का फॉर्मूला होता है COOH. So this can also be written as H2C2O4. Now what is the oxidation state of carbon in oxalic acid? Let it be Z. Let the oxidation state of each atom of carbon in oxalic acid be Z. Oxidation state of hydrogen is +1 and oxidation state of oxygen is -2. Molecule of oxalic acid is neutral, so total charge on the molecule is 0. Now 2 atoms of hydrogen, so it can be written as 2 into 1 plus 2 atoms of carbon, so 2 into Z plus 4 atoms of oxygen, so 4 into -2 is equal to 0. So this is equal to 2 plus 2Z minus 8 is equal to 0. Solving, Z will be equal to 8 minus 2 divided by 2, which is equal to +3. So oxidation state of each atom of carbon in oxalic acid is 3. Now when oxalic acid is treated with KMnO4 in acidic solution in acidic medium, oxalic acid changes to CO2. Now in carbon dioxide, the oxidation state of carbon will be, let the oxidation state of carbon in carbon dioxide, let it be Y. Oxidation state of oxygen is -2. So oxidation state of carbon in carbon dioxide can be calculated as, now there is one atom of carbon in each molecule of carbon dioxide. So 1 into Y plus there are 2 atoms of oxygen in one molecule of carbon dioxide. So 2 into oxidation state of each atom of oxygen, that is -2, and this is equal to 0. So Y minus 4 is equal to 0 or Y is equal to +4. So in oxalic acid, each atom of carbon has oxidation state of +3, and in carbon dioxide each atom of carbon has oxidation state of +4. So when oxalic acid is changing into carbon dioxide, the change in oxidation number of carbon will be 4 minus 3, that is 1. So change in oxidation number of carbon will be 1. So the answer here will be 1. The normality of H2SO4 in the solution obtained on mixing 100 ml of 0.1 m H2SO4 with 50 ml of 0.1 m NaOH is dash into 10 to the power minus 1. First of all, find the number of equivalents of H2SO4 and number of equivalents of NaOH. The reaction between H2SO4 and NaOH will be, it will form H2SO4 plus NaOH will be equal to Na2SO4 plus H2O. Now milli equivalents of H2SO4, since the volume is given in milliliters, it will give milli equivalents of H2SO4. Milli equivalents of H2SO4 will be equal to molarity into volume into valency factor of H2SO4. Molarity of H2SO4 is given as 0.1 m. Volume of H2SO4 is 100 milliliter. So 0.1 into 100 into valency factor of H2SO4 is 2. So this is equal to 20 milli equivalents. So this is the milli equivalents of H2SO4 present. Next, milli equivalents of NaOH. This will be equal to molarity into volume into valency factor of NaOH. So molarity of NaOH is given as 0.1 m and volume of NaOH is given as 50 milliliter. So 0.1 into 50 into valency factor of NaOH is 1. So this is equal to 5 milli equivalents. Milli equivalents of NaOH is less than that of H2SO4. So amount of NaOH present is 5 milli equivalents. So 5 milli equivalents of NaOH will react with 5 milli equivalents of H2SO4. So amount of H2SO4 remaining is equal to 20, that is the initial amount of H2SO4 minus amount of H2SO4 that reacted with NaOH, that is 5 milli equivalents. So this is equal to 15 milli equivalents. Now normality of H2SO4 will be equal to normality of H2SO4 will be equal to equivalents of H2SO4, that is 15 into 10 to the power minus 3 equivalents. To convert milli equivalents into equivalents, it has to be divided by 1000, divided by the volume of solution. Now what will be the volume of solution? 100 ml of H2SO4 is mixed with 50 ml of NaOH. So total volume of solution is equal to 100 plus 50, which is equal to 150 milliliter, and to convert it into liters, this will be 150 into 10 to the power minus 3 liter. So normality of H2SO4 will be equal to 15 into 10 to the power minus 3 divided by 150 into 10 to the power minus 3. 10 to the power minus 3, 10 to the power minus 3 cancel. 15 ones are 15, 15 tens are 150. So this is equal to 0.1 n, or this can also be written as 1 into 10 to the power minus 1 n. So answer here will be 1. 1 into 10 to the power minus 1 n. On reaction with a stronger oxidizing agent like KiO4, hydrogen peroxide oxidizes with the evolution of oxygen. This is oxygen, O2. The oxidation number of iodine in KiO4 changes to dash. Now here KiO4, in KiO4 the oxidation state of iodine is +7, and in KiO3 the oxidation state of iodine is +5. So the oxidation number of iodine which is present in KiO4 changes to +5. The answer will be 5. Now how to calculate the oxidation number of iodine? Oxidation number of iodine, let it be Z. Then oxidation number of potassium is +1, and each atom of oxygen has oxidation number of -2. And this KiO4, it is a neutral molecule. So 1 plus Z plus, there are 4 oxygen atoms. So 4 into -2. So 4 into -2 is equal to 0. So this is Z plus 1 minus 8 is equal to 0, and Z is equal to +7. Similarly here the oxidation number of iodine is calculated as +5. So the answer is oxidation state of iodine changes to +5. So iodine is undergoing reduction and it is oxidizing H2O2. The amount of charge in Faraday required to obtain 1 mole of iron from Fe3O4 is, मतलब कि Fe3O4 से अगर हमें obtain करना है 1 mole of iron, then what is the amount of charge required? Now if you write the balanced equation, this will be Fe3O4, 1 mole of Fe3O4 will give 3 moles of iron. First of all, find out the oxidation state of iron in Fe3O4. Let the oxidation state of iron, each atom of iron in Fe3O4 be Z. Now how many atoms of iron are there in one molecule of Fe3O4? There are 3 atoms of iron. So total oxidation state of 3 atoms of iron will be 3 into Z, that is 3Z, plus each atom of oxygen has oxidation state of -2. So 4 atoms of oxygen here will have oxidation state of 4 into minus 2, which is equal to minus 8. So this becomes 3z plus minus 8 is equal to 0, or this can be written as 3z minus 8 is equal to 0. From this, z is equal to 8 by 3. Means each atom of iron has oxidation state of 8 by 3. So each atom of iron in Fe3O4 will accept 8 by 3 electrons. It can also be said that 1 mole of Fe3O4 contains 3 moles of iron. So 1 mole of iron atom accepts 8 by 3 moles of electrons. Therefore, 3 moles of iron. 1 mole of Fe3O4 contains 3 mole of iron. So 3 moles of iron will accept 8 by 3 into 3, which is equal to 8 moles of electron. One molecule of Fe3O4 contains 3 atoms of iron. Each atom of iron has oxidation state of 8 by 3. In neutral iron atom or metallic iron, the oxidation state of iron is 0. So change in the oxidation state when one atom of iron in Fe3O4 is changing into metallic iron, the change in oxidation state is from 8 by 3 to 0. So change in oxidation state is 8 by 3 for each atom of iron. So each atom of iron accepts 8 by 3 electrons. Or it can also be said that 1 mole of iron accepts 8 by 3 moles of electron. Therefore 3 moles of iron will accept 8 by 3 into 3, that is 8 moles of electron. Therefore total electrons accepted by 1 mole of Fe3O4 is 8 moles of electron to change into 3 moles of metallic iron. Now to obtain 3 moles of iron atom, 8 moles of electron is required. Therefore to obtain 1 mole of iron atom, 1 mole of iron, the moles of electron required is 8 by 3 moles of electron. So according to the question, the amount of charge in Faraday required to obtain 1 mole of iron. So to obtain 1 mole of iron, 8 by 3 moles of electron is required. Now 1 mole of electron carries a charge of 1 Faraday. Therefore 8 by 3 moles of electron will carry a charge of 8 by 3 Faraday, which is equal to 2.67 Faraday, and in nearest integer the value will be 3 Faraday. So the correct answer here will be 3 Faradays of charge, which will be required to obtain 1 mole of iron from Fe3O4. Here the change in oxidation state per atom of iron is 8 by 3. This is change in oxidation state per atom, and there are 3 atoms of iron in one molecule of Fe3O4. Therefore the total change to convert 3 atoms of iron to metallic iron, the total change in oxidation state will be 3 into 8 by 3, which is equal to 8. So 1 mole of Fe3O4 accepts 8 moles of electron, giving 3 moles of iron. So to obtain 1 mole of iron, 8 by 3 moles of electron will be required, which is equal to 8 by 3 Faraday, which will be equal to 2.67 Faraday, and the nearest integer value will be 3 Faraday. The disproportionation of MnO4 2- in acidic medium resulted in the formation of 2 manganese compounds A and B. 2 manganese compounds A and B. If the oxidation state of manganese in B is smaller than that of A, then the spin-only magnetic moment value of B in Bohr magneton is. Oxidation state of manganese in B is smaller than that of A. MnO4 2- in acidic medium will change into MnO4- and MnO2. In MnO4 2-, oxidation state of manganese is +6. Here in MnO4- it is +7, and in MnO2 it is +4. So manganese is undergoing simultaneous oxidation and reduction. Oxidation state of manganese in B is smaller than that of A. So here MnO2 is the compound B. You have to find the spin only magnetic moment value of B. Electronic configuration of manganese is, the outer shell configuration will be 3d5 4s2. So manganese in +4 oxidation state means it has lost 4 electrons. So its configuration becomes 3d3. So there are 3 unpaired electrons. In the d subshell there are 5 d orbitals. So there are 3 unpaired electrons in the d orbitals. Now the formula to find the magnetic moment is equal to square root of n plus 2. What is n? N is equal to number of unpaired electrons, which in this case is 3. So the value of magnetic moment is equal to square root of 3, square root of 3, 3 plus 2, which is equal to square root of 15, and square root of 15 is 3.87. So this is the value of magnetic moment. Now how to find the oxidation state of manganese? If you want to find the oxidation state of manganese in MnO4 minus, then just assume that the oxidation state of manganese in MnO4 minus, let it be Z. Now there is only one atom of manganese, so 1 into Z plus 4 atoms of oxygen, 4 into -2, and this is equal to -1. Total charge on the ion is -1. So Z minus 8 is equal to -1. From this the value of Z is equal to +7. For a reaction given below is the graph of natural log of K versus 1 by T. On y-axis natural log of K and on x-axis 1 by T. The activation energy for the reaction is equal to dash calorie per mole. Nearest integer you have to give the answer. Value of R is given as 2 calorie per Kelvin per mole. The Arrhenius equation is K is equal to A e to the power minus EA by RT. So this can be written as natural log of K is equal to minus EA by RT plus natural log of A. Now slope will be equal to y by x. What is the value on y-axis? It is 20, and what is the value on x-axis? It is 5. So the value on y-axis 20 corresponds to 5 on x-axis. So slope is 20 by 5 and it is also equal to EA by R. What is the value of R? Value of R is given as 2 calories per Kelvin per mole. Solving value of activation energy will be equal to 20 by 5 into 2. So this is 5 4s are 20 and 4 2s are 8. So value of activation energy is 8 calories per mole. So the answer here will be 8 calories per mole. For a cell, this is the copper anode and this is silver cathode. Concentration of copper ions in solution is 0.001 mole per liter. Silver ion is 0.01 mole per liter. Cell potential is given as 0.43 volt. The magnitude of standard electrode potential for copper is dash into 10 to the power minus 2 volt. Reduction potential of silver is given. Now what is the reaction taking place at the anode? At the anode the reaction taking place is copper changing into copper ion and it is losing 2 electrons. And the reaction at the cathode? At the cathode silver ion is accepting 1 electron and changing into neutral silver atom. Now to make the number of electrons equal at both cathode and anode, multiply this whole equation by 2. So this becomes 2 Ag plus 2 electron forming 2 Ag. Now on adding the reaction at the cathode and anode, number of electrons get cancelled and the redox reaction that is taking place is copper plus 2Ag plus, forming Cu2 plus 2Ag. This is the redox reaction taking place in this cell. Now E cell is equal to E naught cell minus 2.303 RT by NF log. Now concentration of the ions present in the solution. See, metallic silver and metallic copper, the concentration is taken as 1. So this becomes log of ions present in the product, that is Cu2 plus ion, concentration of Cu2 plus ions, and concentration of silver ions, and it will be raised to the power 2. What is 2? 2 is the stoichiometric coefficient of silver ion in the redox reaction. Now E cell is given in the question as 0.43 volts. E naught cell minus now 2.303 RT by F. This value is given in the question as 0.06 divided by N. N is the number of electrons. So number of electrons taking part in this redox reaction is 2. Log concentration of copper ions is given in the question as 0.001. This can also be written as 10 to the power minus 3. And silver ion concentration is 0.01 and it is raised to the power 2. So this becomes 10 to the power minus 2 raised to the power 2, which is equal to 10 to the power minus 4. So here it can be written as 10 to the power minus 3 divided by 10 to the power minus 4. Now log 10 to the power minus 3 divided by 10 to the power minus 4 is equal to log 10. This 10 to the power minus 4 goes to the numerator and this becomes log 10 to the power minus 3 into 10 to the power 4. Now minus 3 plus 4 is 1, so this becomes log 10 to the power 1, which is equal to log 10, and log 10 value is 1. So this entire term becomes equal to, this term becomes equal to 1. 0.06 divided by 2 will be 2 ones are 2 and this is 0.03. Solving this equation, E naught cell can be written as 0.43 plus 0.03, which is equal to 0.46 volt. And what is the value of E naught cell? E naught cell is E cathode minus E anode. What is the cathode here? Cathode is the silver electrode, and a reduction potential value for cathode is given as 0.80 volt. So E naught cathode minus E naught anode is equal to 0.46, and this is 0.80 minus E naught anode. Anode is the copper electrode, is equal to 0.46. Solving E naught anode, that is reduction potential of copper electrode, will be equal to 0.80 minus 0.46, which is equal to 0.34 volt. 0.34 volt can also be written as 34 into 10 to the power minus 2 volt. So here in the fill in the blanks it will be 34. So the reduction potential of copper is 34 into 10 to the power minus 2 volt.